Before the event starts, I would like to invite the guests to be seated in front of Zoom as the conference will begin soon. May I request all of you to be seated in front of Zoom as the conference will begin in few minutes. Before we proceed, please allow me to read to you the online conference rules. Kindly change your Zoom ID according to the participant's ID. Please mute your microphone during the conference. We encourage participants to activate their videos during the conference. Please ensure a proper appearance. All participants are required to fill out the online attendance form, which will be provided through Zoom chat box. Honorable keynote speakers and distinguished invited guests, ladies and gentlemen. Good morning and welcome to the International Conference, the second annual Advanced Technology and Vocational Engineering Education, ATASEC 2020, and National Conference SNGPR 2020, State Polytechnic of Malang, on the theme, Welcoming Industry 4.0 through Advanced Technology, Science, and Vocational Engineering Education. I extend to you all our warmest welcome to attend this conference. It is our privilege and honor to welcome Professor Nobuo Funabiki from Japan. Kindly let me say hello in Japanese for Professor Nobuo Funabiki. Ohayo gozaimasu, Funabiki sensei. Yoroshiku onegai shimasu. Also, our warm welcome and thank you for Professor Rosli bin Umar from Malaysia, Mr. Anang Yahmadi, Mr. Nana Sutiksna, and Dr. Anggit Murdani. We are grateful for our health and happiness, as well as the opportunity to gather in this conference despite of COVID-19. The conference program are opening ceremony and greetings, presentation by keynote speakers in this morning, and parallel presentation in the afternoon. This conference provides a great opportunity for participants to share their applied research findings and the experience in dealing with advanced technology and vocational engineering. Hosted in Malang City, the State Polytechnic of Malang has the honor to present you this conference. Excellencies, participants, ladies and gentlemen, to begin with, I would like to invite the chairman of the second annual Advanced Technology and Vocational Engineering Education, conference to deliver the short report. Ladies and gentlemen, please welcome Dr. Indrasno Sirajuddin.
Thank you, Dr. Ratih Hapsari, for the time given to me to greet everybody in this conference. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Firstly, I would like to start by wishing you all and your family my personal for your health and safety in these difficult times. I would like also to take this opportunity to express my profound gratitude to all those doctors, nurses, workers who are serving so selflessly on the front lines of this health crisis. Secondly, I would like to express my great appreciation to all participants and keynote speakers, Professor Nobuo Funabiki from Okayama University, Japan, Professor Rusli bin Umar from University Tun Hussein on Malaysia, Mr. Anang Yahmidi from PT PLN, National Electricity Company of Indonesia, Mr. Nana Sutiksna, a QA and a QC practitioner in oil and gas industries, and Dr. Anggit Murdani, a senior lecturer and vice director for student affairs in the State Polytechnic of Malang, for providing us their valuable time for sharing their thoughts, ideas, and last but not least, thanks to committee members to make this virtual conference of ATASEC 2020 and NSCN GBR happen today amid of the COVID-19 pandemic. COVID-19 is causing tragic loss of life, and the measures needed to fight have turned out world upside down, affecting billions of people and stopping economies in their tracks. Education has been hit particularly hard by the COVID-19. Billions of learners out of school, millions of schools and university closure worldwide. As schools around the world transition to online learning during the COVID-19 pandemic, students, parents, and educators are all wondering what this means for education in the future. It might seem difficult to predict how the future will unfold. Classroom education is the best education method, but online learning can be acceptable and may be credible in the future. Not only in the world facing a pandemic, but at this moment we are also in the midst of digitizing every industry and aspect of our society. This means many parts of our life that used to be spirited will now converge. The pandemic is simply accelerating that process. We cannot rely on students to take the burden of the transition. Our educational system must also transform. Likewise, the second ATASEC on SNGBR have also been transformed to be a virtual conference meeting. Our most priorities is safety for all keynote speakers, participants, committee members, and also anybody who is involved. We will try our best to organize this conference to be successful. I would like also to report to our principal of the State Polytechnic, Mr. Awan Setiawan. In this moment, he is represented by Mr. Supriyatna Adi Suwigno, the Vice Director of Academic Affairs, that the ATASEC 2020 and SNGBR have attracted 145 researchers, academicians, practitioners who have come from different field of study background in engineering to present and to share their contribution to the science and knowledge in this conference. I would like also to inform that this event is publicly broadcasted live in YouTube to have a broader audiences and strengthening the impact of this event. Finally, on behalf of the ATASEC 2020 and SNGBR committee, I wish our respected keynote speakers, presenters, and all participants to have fruitful discussion in this conference. Please stay safe and healthy. Thank you very much.
Thank you, Dr. Indrasno Sirajuddin, for the short report. Distinguished guests, ladies and gentlemen, I am honored to invite our principal to address the opening speech. Ladies and gentlemen, please welcome Mr. Supriyatna Adiswigno.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, dear colleagues. It gives me great pleasure to extend to you all a very warm welcome on behalf of Polytechnic Negeri Malang, and to say how grateful I am to all guests and presenters of the second annual Technology, Applied Science and Engineering Conference ATASEC 2020 and 11th Joint National Seminar on Engineering 2020. I also would like to convey my special appreciation to Mr. Indrasno and Mr. Rosa Andre as the chairman of the conference and all committees, which come from a combination of all engineering majors in Polytechnic Negeri Malang, who are responsible for the implementation of this conference. We are very grateful to be able to continue to hold this conference at the second time, despite of the limitation due to COVID-19 pandemic. Our plan was to welcome all participants of conference to visit our beautiful city, Malang. However, even though we cannot meet face-to-face, we can still carry out this conference virtually with enthusiasm and joy. The ATASEC 2020 has a theme welcoming Industry 4.0 through advanced technology, science, and vocational engineering education, as for SNGBR 2020 theme, implementasi penelitian terapan multidisipliner bidang rekayasa melalui kolaborasi pendidikan tinggi vokasi dengan industri. This term will be a media for sharing knowledge from researchers and industry from all fields of advanced technology and science. This conference will be attended by 5 distinguished keynote speakers: Prof. Nobu Funabiki from Okayama University, Japan; Prof. Madya Dr. Rusli bin Umar from University Tun Hussein On, Malaysia; Dr. Eng Anggit Murdani, Vice Director on Student Affairs and Senior Lecturer in Machine Mechanical Engineering Department, Polytechnic di Malang; and Senior Anang Yahmadi MNSC from PT PLN, National Electric Company Indonesia; and Mr. Nana Sutiksna, Practitioner QA/QC from Oil and Gas Industry. Please accept my high appreciation to all 5 keynote speakers for joining here with us today. Ladies and gentlemen, such a conference is an extraordinary opportunity as a good time to share knowledge from a variety of affiliated and also a variety of concentration in the scope of the field of advanced technology, science, and vocational engineering. education. Thank you also to all experts, researchers, lecturers who come to share their knowledge today. I am sure and rewarding exchange today. I wish you all a very success with this important conference, and I look forward to learning about the outcome. So let me now open this conference officially by wishing you a delightful and vibrant day. Bismillahirrahmanirrahim. Thank you. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for the Principal of State Polytechnic of Malang for the meaningful opening speech. We are now continuing our meeting to the next agenda, that is to hear the keynote speech, which will be delivered by Professor Nobuo Funabiki and Professor Rosli bin Umar. The keynote speech will be chaired by Dr. Ervan Rohadi. Ladies and gentlemen, please welcome Professor Nobuo Funabiki and Professor Rosli bin Umar.
Good morning, ladies and gentlemen. Welcome to keynote session. We have two keynote speeches in the first keynote sessions. Let me introduce myself. My name is Ervan Rohadi from IT Department, State Polytechnic of Malang, and I'll be serving as your moderator today. You'll be hearing the first presentation from Prof. Nobuo Funabiki on this very timely subject, but before we get started, I want to take a few minutes of your time. Now moving along to our sessions, please welcome Professor Funabiki, who will be speaking to us on project of programming self-study tools. Before we start the presentations, let me introduce a short bibliography of him. Professor Nobuo Funabiki, currently as professor at the Department of Communication Network Engineering, currently Department of Electrical and Communication Engineering of Okayama University. His research interests include computer network, optimization algorithm, educational technology, and web technology. He is a member of IEEE, IEC, and IPSJ. Professor Nobuo Funabiki has been the associate editor in chief in Journal of Communication since 2016. He was the chairman of IEEE resume sections 2015 to 2016. Ladies and gentlemen, please give a round of applause to Professor Funabiki by raise your hand. Professor Funabiki, time is yours. Please start your presentation.
So because mic is muted, now I changed the state. So thank you for a great introduction of me. Actually, I visited your institute several times. Always the people in your institute, not only in your institute in Indonesia, always my friends. So actually, this time, to tell the truth, it's very sad for me. When you offer me do this great opportunity to talk in front of the distinguished guests, I was so happy. Oh, I can go to Indonesia, Malang. Malang is a particularly good city, I think, because it's a high place. And I often visited Surabaya. Surabaya is also nice, but very hot. But in that sense, Malang is relatively cooler and nice view. People are friendly, kind. Besides, food is very nice. So I was so excited. But however, that current situation didn't allow me to visit you. So I have to talk from my office. It's very sad. But however, still I'm happy I can introduce my works, the project of programming self-study tools. And also, I want to share our activities with these distinguished guests. Particularly, actually, I have an activity to promote the use of our tools in universities in Indonesia. So I want to introduce. Also, I have similar activities in Myanmar. So after you see my understand our activities and have an interest in our project, please have a contact with me. I want to work together with you. So I want to start my talk. Okay. I think. Okay. Sorry. So can you see the slide, everybody? Okay, so I want to start this my talk. So before that, I checked the Indonesian word, selama pagi. So before I remember, but as become old, I easily forget. Selama pagi, terima kasih. Okay. So my name is Nobuo Funabiki. I'm currently a professor in Okayama University, Japan. So first, I'd like to briefly introduce our campus. This is a clock tower, like a symbol of our campus. So the other side is our main gate. So if you enter our campus from the main gate, you can see this building. Actually, this is library. So unfortunately, due to the COVID-19, now not many students coming. The location of Okayama is the west side in Japan. So if we visit our campus, first flight to Osaka Kansai Airport, then by taking a bus, it allowed 3 hours from Kansai Airport. There is a direct route from Kansai Airport. Okay, there are several places to see, including Korakuen Japanese Garden or Fine Art Museum. This is a campus view. So our campus is large, very big. So maybe much larger than Malang Polytechnic, I think, from my observation. So actually, this is the third largest campus among Japanese universities, maybe among the national Japanese universities. So our university is one of the general universities. So one of the largest national universities in Japan. So our university covered almost every areas, like education, economy, science, medical, dental, agriculture, of course, engineering. So if you are the engineering, I think. So even the other areas. So we are welcome for your studying here. The size of the universities is stable. So currently, about 13,000 students studying. 10,000 are undergraduate, 3,000 are graduate students. So that is one of the largest Japanese national universities. Then I moved to the main topic, project of self-study tools. So this self-study tools, actually, we started for Java programming. So we call it J+. So first, I will explain the details of our self-study programming tool for Java programming. Okay. Sorry, before that, I have to briefly introduce the general background. So I think programming, I'm sorry, this time the engineering, all of the any engineering fields may attending this conference, so including mechanical engineering, control engineering, electrical, chemical, and biochemistry, maybe. But however, I'm sorry, I'm a IT person, IT guy. So my talk is maybe focused on the IT. So at least in the IT, programming is most important. Particularly now due to the COVID-19, so people have to say study in the home through the internet. Then by say using various IT tools, so the student can study or people can work together. So these IT systems, IT tools are working based on the programs. Without the programs, without good advanced programs, we cannot do anything. Just hardware is not enough. Now is the age of software, programming, ideas. So our new ideas, our services, new services, new education styles can be achieved by programs, I think. So, I hope that every student, every graduate of IT departments can develop the high programming abilities. Okay, then what they have to do? Programming, just reading like a textbook. This is not textbook. This is Indonesian Indonesian tour guide book. So to this textbook, not enough. Out of practice, out of solving the IT equation exercise, program is absolutely necessary. Without these practical exercises, they cannot improve the program abilities. However, the teacher side, the resource is limited. So one teacher have to teach a lot of students. I heard from Mr. Yang in your institute. So the one teacher have to teach like 100 students, 200 students. So it's impossible to check the answers, their assignments from such a huge number of students. So to help this programming education, we developed the programming self-study tool called Java, called the J+ for Java programming plus. Now we are for the Java, we almost finished our project. Maybe we have to do something still, but now the other languages, I think we think getting more important. So we are now extending our activity, our tool for Java programming to C programming, Python programming, also Android programming. Maybe C is a basic language. So this time we compare the C programming and Java programming. C is much simpler. So not many grammars actually. So this is a good program language to start studying the programming language, I think. So however, it's not so advanced. I think now people start using Python because Python has a rich library. So if you want to use machine learning, AI, deep learning, so people using Python. Okay. Besides the rich library, Python has a very advanced grammar. So it's a short source code. Later I will show you to compare with the Java. we can write the advanced programs with very short code. So it's a good feature. So I think students should learn Python program besides C and Java. So we are now shifting to these program languages. So this table I pick up from some website. So they compare. There are several websites. They're comparing the popularity of program languages. So this site says Java is #1 because here is you can see Oracle. So Oracle is a developer of Java. So they still claim Java is #1. But however, some site says Python is #1, or JavaScript is very popular. So anyways, Java, C, Python, and JavaScript. These are very popular now. Okay, so that's the reason we targeting Java, C, Python. So later I will explain the more details about tools. So we developed the tools. So that tools is basically written in, say, Java, JavaScript, and maybe English. So we can besides Japanese, so any people who understand English or program can use our tools. So we are starting the project to promoting our program self-study tools to the several universities in Indonesia and Myanmar. So in Indonesia, unfortunately, only one university, your university, State Polytechnic of Malang, because of my current student, Mr. Yan. He is very active. He helps us to promote these tools. But in Myanmar, I have several collaborations with these universities. So yesterday, I had a meeting by using Zoom with a teacher in Yangon University. Yangon University is the oldest university in Myanmar. So we are actively working. So we discuss how to apply, how to assign our tools to their students. Actually, they are already started. Okay. So if you are the audience have interest in our activities, please let me know. Please contact with me. In the last, I will show you my contact address. Okay, so you're welcome. So I ask my Indonesian students to discuss with you. Of course, I will discuss, but you know, you can, if you my Indonesian student talk, it's easier. You know? So yesterday, I asked my Myanmar students to talk with the teacher in the Yangon University. Much easier. If I talk, it takes 2 hours, but that's 30 minutes, very fast. So this is a photo of my group. So actually more students there, but we took this photo on last March 25. So that they had a graduation ceremony. So you know this like green or red sheet is a certificate. Okay, so here these 5 persons are Indonesian students. So one of them, so center, he graduated that time. He is a lecturer in Penns, Surabaya. So the others are still studying. So he is Mr. Yang. Okay, you know well. So blue are my Myanmar students. So 4 ladies and 1 boy. So 4 studying on this project. So yesterday I asked them to join the meeting with a teacher in Yangon University. So actually they are communicating with them. So because I cannot handle everything, so I asked these students so to help this project. Actually, this is also good things for them. So they can advance their research works because they are studying on the self-study tools. Okay, so it's a good project for both sides, I believe. So now I move to the details of our tool. First, for Java programming. So J+, we call it J+, Java Programming Learning Assistance System. J+ is basically it's a web application system. So we implement the code on this platform. So in J+, we develop the several different types of programs. Some are easy, some are more difficult, because programming needs different levels. So we cannot assign the hard programs to the new students. Okay, so the new student, novice students should start from the easy ones, more like a basic, asking more basic knowledge on the programming. Then gradually they should solve the more difficult or more complete programming. So last one is the code writing. Code writing is ask a student to write some source code from scratch. But we believe we shouldn't ask the student from the beginning to write the source code. Okay, they say afraid that some students don't like the programming. So we should start from the easy ones. So we develop several different types of programs. Okay. So the feature of our system, because as I told you, so this is a self-study tool. So the student answer should be marked automatically. The answer is correct or not. So without the teachers are checking, so students should know this is correct or not. So for automatic marking, we adopt two methods. Actually, three methods. Actually, two methods. One is a string matching. So the system keeps the correct answers, like a word. So the student answers compare with this word. If they are exactly the same, it is correct. Otherwise, incorrect. So second one is comparing. Maybe I'm saying there's nothing. So another one is testing. So we developed the teacher have to prepare the special code called the test code. The test code run the source code by the students and checking. So this is correct or not. Okay. So for the string matching, we using string matching. We developed these 3 or 4 programs. Okay. For the testing, we develop these programs. Data I'll explain one by one. Okay. So due to the automatic marking, so students submit to the web server. So then server checking, is it correct or not? Then the feedback, the marking result immediately. So if the say student find some mistakes, so they can correct and resubmit to the server. Also, the system gives us some hint if the student answer is not correct. So during that time, teachers does not need to do anything. Of course, teacher have to prepare the assignments, so questions, and upload to the server. But besides that, no. So after the students solved these assignments, just checking the student activities. That's all. So even the few teachers can handle a lot of students. So the teacher can assign a lot of exercises to many students. Okay, so that is our goal of this project. Okay, so even for assignments, you don't need to worry. We already developed some implement many assignments. So for the Myanmar universities, even the state of Malang, Polytechnic Malang, we gave our developed assignments to their students. So I don't know, it is okay. So of course the teacher can customize, can change, but so far they are solving, they are using our developed, our made assignments. So just copy, okay? So you don't need to worry. We can discuss how to modify or how to evolve. Okay. Then I will explain the details of each problem one by one. So element filling blank problem. So in this problem, student is given this kind of source code. So this source code has several blanks. Then students have typing the correct word to each blank, like a class, semicolon, in data, or curly bracket. Then this typed word is compared with the correct one. Correct ones are already stored in the system. Okay, so by through the string matching, the correctness of the student answer is marked automatically. Okay, this time we make a blank for reserved words in Java, like int, data type, public, class, like that one. Also identifiers, variable, class, method. So also this kind of like a control symbol or a block symbols of the source code. So we developed the program automatically extract these elements and classify them and make blank automatically. Okay. Then so teacher just choose some good source code like this one. So then our system automatically make a blanks and store the correct answers in some files. Okay. So I skipped that part. So when the student access to our system, the students see this kind of source code. Okay. Then student request to type in the blank, like here class main or no blank, like this one. Then click the answer. So the system automatically marking the correctness. So pink means not correct. So here is a 4, not a 5. Okay, so like that one. So in this, so the students, if the students find some mistakes, pink forms, they try again. Okay, so that is that kind of problem. Okay, so this is the source code. Fill in the proper words to each blank and click answer. White correct and pink mistake. Then collecting the mistakes and resubmit. Okay, repeat. So without the help of the teacher, so students can continue the studying the kind of programming. So for the programming, so first the students should read. We should read the out of source code. So first they have to understand how to read the source code, how the source code behaves, what the grammar. Okay, so before writing the source code programs, they should read a lot of source code and familiar with the structure of the source code. So this kind of problem can help the students to do that activity. Okay. So next is the code completion problem. So code completion problem is just a simple extension of previous element filling blank problem. The difference is blank forms not appear, because if there are blank form, it's become easier. Instead, all the statement should be complete. So each statement has missing element, missing word. So we don't specify where is the missing, disappear. So students have carefully read the source code and insert the proper words to complete a whole statement. Okay. So this is say example source code for code completion problem. So if you see carefully something missing, like like a while, or else, or even I think public static void main, so static. So if you're familiar with Java program, there are several words are missing, public class. So students have to carefully read the source code, given source code, and find what word, where missing. Okay, so actually this is a correct answer. So students are expected to fill in like red word class static in file. Okay, this is called a code completion problem. Because the previous element fill in blank problem, so students know where is missing. So it becomes easier. So they can solve just randomly typing in case. But this time, no. So student must understand the grammar, must understand the behavior. So semantic, syntax, semantic, both. Otherwise, they cannot reach the correct answer. Okay. So after they finish the element fill one problem, so students, we expect students move to this problem to brush up their knowledge of code reading. Okay. So actually, the answer form, each statement is one form. So so the students, so the system gives a form of one form, including the whole statement. So some words are missing, so type in there, and the system compare whole statement with the correct answer. Okay, so like this one. So so this is a student interface. So again, pink means incorrect, mistake. White is correct. So something missing. So public void, static void means static is missing. So students have to type in static. Besides, there is yellow. Yellow is correct grammatically or semantic, so correct. However, the writing, code writing is not correct. I mean, so we have to be careful of how to write a source code. So due to the coding rule, it is better to insert a space before equal, after equal. So num space equal space num. That is recommended by the coding rule. So if the student writing doesn't satisfy the coding rule, we change the color to yellow. So by solving this problem, also students can learn how to write a correct say source code following the coding rule. So I believe the good student always write a source code, say, in the beautiful way. So there is a book, I think, Beautiful Code or something. So code writing must be beautiful. How? Follow the coding rule. Okay, so by solving these problems, we expect the students also study the coding rule besides the program. Okay. Then I move to the value trace program, third one. So this time, in this problem, we request the students to trace, to say, understand the real values. What values? 10, 20, A, like that one, of some important values in the source code. Particularly, we consider the source code for data structure like a queue, stack, or algorithm, insertion, sorting, or graph algorithm, like that one. So stack queue, insertion sort, selection sort, or a graph algorithm, diagnostic prim. So then a student can study, again, the code reading, more advanced programs. More advanced means the program is just not a simple one, just say Java Hello World, no. So the program is for representing some data structure or algorithms. So I think before eventually students have to understand how to implement these source codes for more advanced topics. But before that, students have to study by reading the existing source codes. Okay. So this is an example for insertion sort. So I'm not sure this is a good or not. So maybe some errors. Okay. So among them, in this source code, actually ARR, maybe we should use array, okay? So ARR, this array is most important because ARR array stores the data to be sorted. So by changing the value inside of ARR, we can, this program can sort, rearrange the data in some way, in the maybe in the single ascending order, I think. So if we can, if the student can trace the values of AR, how the value of AR is changing, that means the student can understand. Also, maybe to understand this program, so students can trace the value of AR. So we ask the student to trace that one. So to make a program, so we add another functions to print out, so to give the standard output of the value of AR here. Then here is the input value to this program. So we assume if we give this like a 10 numbers, so what the result? How the program works. So the problem is like this one. So input is data, so just copy. So here we so just copy. Then this data, how they changed. So if they understand what is the insertion sort, also they understand how it is actually this loop is most important. How it is worked, so student can find how these numbers it changed. Okay, so actually this is the answer. Okay, so reading this source code and considering the input, so then they understand how the program is worked. Now, what is the inside of the value of each the array of AR important value. So student can answer these values. If the student can understand, can solve, that means the student at least understand the source code for this insertion sort. Okay, that is a value trace problem. So next one is a code writing problem. From here, we use another marking method by using a test code on JUnit. So this test code approach is called a test-driven development method, TDD method. So in this approach, so first people write a test code first before writing a source code. So test code first approach. So what is test code? It's also the Java source code, but only for testing the specified function in the source code. Okay. So first we write a test code, then write a source code people. Then using the test code, test the source code and modify. Modify the source code based on the test results. Okay. So by repeating this testing and modification of the source code, so we can complete the source code that satisfies the required functions, specifications. So we use a tool called a framework called JUnit. JUnit is a software framework to allow this approach. So now in the IT industries, many people are using this tool for Java programming. Okay, so it's also JUnit is written by Java. Okay, so it's friendly design. Okay, so here I explain the briefly what is a test code, how we implement. So for this simple example, I use my math class plus method. Plus method accept the two integer values AB and return the addition integer. Okay, very simple. So no exception, nothing. So this is a test code to test this source code correctly. Okay, here you know my mask class instance is MA is object is generated from here. Then plus method is applied, and the result is stored in this result. Then compare. The 1 plus 1 means 2. So 2 and 2 are compared. If they are equal, it is correct. Otherwise, not correct. So by actually the test code running the source code, the class or method, we can check the correctness of the source code. So test code is like a main method to run the source code. Okay. So here we have to observe. So we give the test code to the student. So students have to understand the test code and extract the information. So we have to use a plus method. Also, my mask class and 2 integer arguments like that one. Okay, so like that one. So so students are requested to write a source code that can pass a given test code on JUnit. So because for automatic marking, automatic checking of the student answer source code, if there is other better way, please let me know. But we know, so this is one of the best, one of the possible approach for automatic marking of the student source code. So we give the test code to the students. The students are asked to write the source code that pass the test code. Okay. However, we also observed this approach has another advantage in the education. So because the test code, as I told you, test code can implement, need to implement the necessary information for the source code, such as names, class names, method names, or how many variables, access modifier, argument, number, data types, so returning data type, exception handling. So these are important to write the source code by using Java. So by using a proper test code, so the teacher can control how to the students write a source code. Okay, because I think students often missing, they don't understand how important the variable names, how important the access modifier. Okay, so we can directly give the important information of writing the source code by giving the test code. Okay, just we ask a student, you should read this test code and write a source code to pass this test code. Then students automatically have to follow the student teacher's instructions. So I think that is a good advantage of this approach, I believe. Okay, so for this problem, so I think this is a kind of test code. So student use this test code. Okay, I see. So we have to implement a test search GCD. Okay, a my mask class. Okay, so then so student have to see here my mask class search GCD method, 2 integer arguments. Okay, so then students have to extract the necessary information to implement the source code from the test code, like class name or method name, arguments, or returning data type. Okay, so these informations have to extract. Then, based on this data, so student can write a source code by following the exact information, class name or method name or argument data types. Okay, then compile submission and test. So if no errors, so returning okay. If some errors, like this message, feedback to the students. So okay, so then students can analyze the unit log. Actually, we have a function to help the student activity. From the JUnit log, we can see which part of the test code caused the error. So actually from here, this say asad equals, it's a test case cause the trouble. Okay. Then from this test case trouble, make a trouble, this information we can the student can extract. So because the plus method caused some errors, so student can know. So of course, students implement this source code. So he checks the plus method. Oh, I see. So there is actually a minus b should be a plus b. Okay, student can understand. So this approach can help the students to debug, to find the errors of the source code also. Okay. So statement fill in blank problem. So it's a say partial coding version of a previous one. So instead of asking to write a full source code, we give the say this kind of source code, almost full. But however, some statements, some lines are missing. So we ask the students fill only limited statements, because to complete a source code from scratch may be difficult. So instead of that one, we give them the partially blank source code. Okay. Then how to choose this blank statement is important. Actually, by we generating a PDG graph of the source code, program dependency graph. So this graph shows the relationship between the statements. Then if some statement has a lot of connections, relationship with the other statements, that node is selected. Okay. Then for the marking, we say from the original source code and fill by the student answer code and make a complete source code and run the JUnit. Okay, the other same. So last, I briefly introduced the software architecture of this J+ server. So here, this is a typical web application system. We adopt the MVC model. But for this implementation, we use the different say language for MVC. For build, we use pure HTML with JavaScript. So for control, JSP, and the model is Java. So it's a normal web application system. Vue is developed by JSP for say, using Tomcat. But however, here we use a pure HTML. But besides, we use a JavaScript. So control is only JSP. Okay. So this is because now HTML5 we can allow we can use the JavaScript. So this JavaScript gives us rich functions on the browser side. Okay, like this one. So again, so the program side on the browser we run the JavaScript program. So the JavaScript controls the student answer to ask request the server and receive like that one. Server the side that implemented by JSP is an interface from the students. And the connection with the database or marking, that is implemented by Java. Okay. So besides the online version, web application version, we also developed the offline version. So because in Myanmar, still many people cannot use the internet easily. So we developed a system for students. Students can access the programs and answer the questions offline. So without the internet, they can solve the questions. Okay. For this one, so teachers download the assignments and give the assignment to students by using a USB memory or whatever, any method. The students can answer the questions on offline without the internet. Okay. Then after that, submit the answers to PC, to user, to teacher by using a USB or something. And maybe teachers can upload to a server. Okay. So actually, we are using this offline answering function to university in Indonesia and Myanmar. So it's easier because without installing a web server, we can assign our assignments to students. Okay. So, so I quickly introduced our current project. So extension to other programming languages. Okay. So again, Java, C, Python are very popular languages. So this is now we are studying developing the value trace programs for C programming. So for C programming, I think important thing is pointers, how to understand pointers. So for example, this source code contains pointers here, okay? So we expect if the student can answer what is the output. So there is a printf. So this statement shows some value on the standard output display. So what displays if the student can answer by reading source code? That means that they can understand the behavior, what meaning of pointer. Okay. Also, this is the value trace program for Python. Python has a different. Yeah.
失礼します。ちょっと何分
I finished.
ですね。はい。
1 minute. Okay.
Okay. Thank
Yeah.
you.
Oh, sorry. 1 minute. I finished. Okay. So this is so the Python tuple array is important. So students should understand what the tuple. Okay. So so if they understand what the tuple, they can understand answer. Besides, we are developing the Android program, Android programming. So this afternoon, one of my students, Jan Voltex, Mr. Yang, present this topic. So please join this URL. So I heard that the room 4. Okay, I don't know the exact time. Please access to his presentation. Okay, so he will briefly explain. And also, if you are interested in our project, please contact with him. Okay, he knows well. So this is a summary. Okay, we propose introduced our project. So programming study tools called J+ or other. Okay, now we are promoting these tools to universities in Indonesia and Myanmar. Okay, so if you are interested in our project, please join us. Thank you for your attention. Terima kasih. Okay, thank you.
Thank you very much, Professor Punabigi, for addressing very interesting topic. Now, if anyone any question, I'm sure Professor Punabigi will be pleased to answer. Please mention your name and your affiliations. There is any question? Okay, Mr. Yuri Arianto, please.
Yes. Okay, thank you, Sensei.
Thank you. Oh, nice to see
My
you
name is
again.
Yuri from State Polytechnic. Allow me to ask about your topic. I think your project is very important to support programming learning for our students. My question, what is your strategy to make your project available for most of students in the world? Strategy for students. Yes.
Oh, strategy to promote our tools.
Yes.
Oh, I see. So actually, I have no ambitions. Okay. Maybe my strategy is like a step by step. If somebody are interested, welcome. Okay. But unfortunately, the language is a barrier. I know. Language, particularly the students. many students cannot communicate well in English. So now in my group, there are several Indonesian students and Myanmar students. So I asked them to have a contact with their home universities, their teachers. So all of them, most of them are graduated from the IT departments in their universities. So through them, I have a contact with their teachers, and I ask them to help this activity. So this kind of, I don't know this is a strategy or not. So this time for your university, I asked Mr. Yan to help this project. Help us. So very good. Okay. So because we cannot do everything. We need say good collaboration. So the people here, also people there. I think this matching or collaboration is also necessary. Otherwise, cannot work well. So I don't want to say open everything to everybody because I'm afraid. So because we cannot support everything. This is the students' research projects. So I'm afraid some errors, some bugs. Sometimes I found the bugs. Even yesterday, the Myanmar student developed the Python programming, some tools. There are some errors. Okay, no correct answers. That can happen, you know. So I'm afraid. Okay, so instead I take this step-by-step approach. So through somebody in that university, we want to share our knowledge, tools, and so use our tools to the students in that university. So I'm sorry, this is correct answer to you or not. So it's okay.
Yeah. Thank you, Sensei. Thank you.
Okay, thank you very much. Any other questions? Okay, Professor Funabiki, I've seen your project that uses test codes to validate the students' answer. The test codes are provided by your team, right?
Yeah.
So how can teacher contribute to make assignment or a question in your project?
You mean how to make new questions?
The teachers, other teachers to contribute to make assignments or questions in your project. Yeah.
Assignments. So here we developed five. Here we show the five problems. Okay, for element fill in blank problem, code completion problem. We developed a program automatically make a question assignment. So teachers have to find the source code because these problems we make blanks for some source code, then give the students. So we need an original source code for each assignment. So if the teacher prepares the source code, so the teacher want to show this source code to the students, then running our program. So automatically we can generate. However, value trace problem, no, still we have to choose which variable so the students should trace, and so the teacher needs some manual operations, but are not difficult. So if they find variables, so that the other say modification of the source code not difficult. Okay, for the code writing problem, so we are using say ID for this problem on the offline. Online, maybe we don't need, but offline, we need an ID like Eclipse. So based on the Eclipse platform, we need we need a test code for each assignment. So the test code teachers have to prepare. There are several tools to automatically generate the test code from the source code, but looks not enough. I think so far we manually generate the test codes for many problems. I think we can share the knowledge, experience, how to make a test code. Also, for the given, for the current assignments, we can offer our test code. Okay. So for the first one, was automatic. Okay. But the others, the manual works necessary. Okay. Is that okay?
Okay. Okay. Thank you very much. It's very clear. So we have 1 minute. If there is any other questions from the audience.
Hi, Professor. I'm Rosli here. Can
Okay,
you hear me?
Professor Rosli.
Yeah,
Okay.
I have a
Professor
question,
Rosli,
Professor.
Okay.
Yeah,
Okay.
I have a question. When you develop this kind of project, J+, what was in your mind for the students level? Is it for beginner level or intermediate level or for advanced level?
Basically beginner level. So,
beginner level.
Yeah, assume the tools are used in the undergraduate programming course, I think. At the advanced level, maybe because the test code approach cannot cover the big project, I think. So advanced level, they should develop, implement some say more complicated program. So I think so far we cannot cover. We do not cover such levels. So I think for the beginner levels, but they can study in the beginning for Java, C, Python. After that, they can study by themselves, I hope, I think. But for the Android programming by Mr. Yang, can cover the more advanced topics. Looks, yeah. To tell us, I don't understand well, so maybe if you are interested, please join his presentation. It's more interesting. Yeah, sorry, I'm sorry. This is for undergrad course level. Okay.
Okay, thank you, Professor.
Okay. Thank you very much, Funabiki Sensei, for addressing this interesting topic and joining us today. Let me say something in Japanese. Honjutsu wa hontou ni arigatou gozaimashita. Iroiro oseru ni natte orimasu.
I'm sorry. I think I do not put my email address, contact address. Please introduce the audience. I'm sorry. I think.
Okay.
Oh, sorry. Here is the contact address. Yeah.
Okay. Yeah.
Yeah.
Okay. Everybody can see the screen sharing. Professor Funabiki email, website, postal mail address, and telephone. So this information we will broadcast to all participants.
I see. So please send a message to this address.
Okay.
Also, please attend. Please contact with him. Okay. Your lecture.
Okay, Mr. Yan. Okay, thank you very much. Thank you very much, Professor Funabiki.
Excellent student. So please contact with him.
Okay. Ladies and gentlemen, once again, please give big round of applause to Professor Funabiki by raise your hand.
Yeah, thank you very much. Yeah, very much. Thank you.
Now, for the next keynote speaker belongs to Professor Rosli Umar from Tun Hussein University, Malaysia. Professor Rosli, how are you today?
Yeah, I'm fine, thank you.
Okay.
Dr. Irfan.
Okay, please welcome Prof. Rosli, who will be speaking to us with title Path Planning in Obstacle-Rich Environment based on Visibility Graph Method. So before we start his talk, I'll take a few minutes of your time. Let me introduce him. Professor Rosli Omar currently is an associate professor in the Faculty of Electrical and Electronic Engineering, FKE, University Tun Hussein on Malaysia. He received his PhD in engineering from University of Leicester. I don't know spelling. Leicester, United Kingdom. Yeah, Leicester. Okay, in 2012. And his research interests are in robotic engineering, autonomous system, and system identification. And he is at present as the Dean of FKE on University Tun Hussein on since 2018. So, ladies and gentlemen, please give applause to Professor Rosli Omar. Raise your hand. Prof. Rosli, time is yours now. Please start your talk.
Okay, first of all, thank you very much to Mr. Moderator, Dr. Irfan Rohadi. Assalamualaikum and very good morning to everyone. Thanks again to Mr. Moderator, Dr. Irfan Rohadi, honorable keynote speakers, Professor Nabu Funabiki, yeah, IR Anang Yahmadi, Dr. Anggit Murdani, and Nana Sotikna. Also, committee members of ATASEC 2020 and all the participants and presenters of ATASEC. Thank you very much to Polytechnic Negeri Malang for inviting me as a keynote speaker in ATASEC 2020 to share my latest research on my area of expertise. Special thanks to Dr. Indrazno Sirajuddin. I think he's the director of this conference, for communicating with me to ensure that I am ready for this conference. And also thanks to all the committee members of this ATASEC 2020. I hope this conference goes well and becomes a fruitful conference as well as achieve its objectives. Today I will be talking about path planning, or to be exact, robotic path planning, path planning using, as mentioned by the moderator, visibility graph methods. It is one of the key aspects of autonomous systems, which is one of the 9 pillars of Industry 4.0. Before I go further, please allow me to introduce my institution, UTHM, or University Tun Hussein of Malaysia, and myself. I am Associate Professor Rosli bin Omar, the Dean of Faculty of Electrical and Electronic Engineering, UTHM, and currently my research is on path planning, where we have proposed a number of path planning algorithms for real-time application. I will explain further in my slides later. We have also published a number of papers in this area of research. Okay, let me introduce my university. My university is UTHM, University Tun Hussein, Malaysia. It is one of the public universities in Malaysia, primarily focusing on engineering and technology. In fact, actually, in Malaysia, we have around 20 public universities under the government, and we are the 15th university, established in 2007. UTHM is strategically located in green suburban environment in Batu Pahat, Johor, which is 3 hours drive from Kuala Lumpur. Maybe I believe that some of you have been to KLIA or Kuala Lumpur, right? So it is around 3 hours driving from KL, and it is 1.5 hours from Singapore via North-South Expressway. And currently our university has around 18,000 students, including international students from 22 countries all over the world. And UTHM has been awarded overall 4-star by QS-Star University rating, with 5 stars in teaching, employability, facilities, social responsibility, and inclusiveness. So this is what I mean. We have 4 stars here in total. So we have 5 stars in teaching, 5 stars in employability, 5 stars in facilities, 5 stars in social responsibility, and 5 stars in inclusiveness. We have been accredited or recognized by these bodies, international and local bodies. Maybe you have seen some of the bodies here, hopefully. As I mentioned just now that UTHM is the 15th public university of Malaysia, and historically UTHM started with what we call Pusat Latihan Staff Polytechnic or Polytechnic Staff Training Center on 16th of September 1993. So we are still young. I think maybe younger than Polynema, I'm not sure. We are around 27 years old right now. And later, in 1996, we have been upgraded into Institute Technology Tun Hussein on or ITO, we call it ITO. And again, in year 2000, we advanced into College University Tun Hussein on. And only in the year 2007, we are a full-fledged university. We are UTHM. So basically, we are already 13 years old as a full-fledged university. The mission of the vision of UTHM is towards a world-class university in engineering, science, and technology for sustainable development. And the mission of UTHM is we are committed to generate and disseminate knowledge to meet the needs of industry and the community, and to nurture creative and innovative human capital based on the Tawhidic paradigm. And our motto is, with wisdom we explore. So that's basically the introduction of our university. In fact, I have been to Malang several times, but unfortunately, I still haven't have the chance to visit Polynema. Maybe in the future, I think, hopefully. Okay. I've been to maybe, if you know, Brawijaya University, the ITN, maybe Wijagama, and several universities in Malang. Also, okay, this is the outline of my presentation. Hopefully, I can finish within 40 minutes from now. First, I will give introduction to path planning, and later I will explain about path planning methods. And later on, I will explain about graph search algorithms. Then I will tell you about some methods in path planning, very established methods, cell decomposition method, Voronoi diagram, potential fields method, feasibility graph, probabilistic log maps, real-time path planning. Okay, this is actually the established path planning method. And let me change this. Okay. And this one actually our research, our current research, our group. We have a group for path planning research. Okay, what is path planning? Okay, path planning basically is a problem of determining a path for a vehicle in a properly defined environment from a starting point to a target point such that the vehicle is free from collision with surrounding obstacles and its planned motion satisfies the vehicle physical kinematic constraints. This is the definition of path planning. Basically, you have to go from point A to from B, from point A to point B. In between the 2 points, you have a lot of obstacles, and you have to avoid the obstacles to get to point B from point A. This is basically the definition of path planning. And there are a number of criteria for path planning. The first thing is you have to consider its computational time. It is very crucial if you are planning to have path planning algorithm in real time. Secondly, you have to consider as well the path length and also the completeness. Path length is very important, especially if you are very concerned about the energy usage, energy consumptions. Okay, because the shorter the path, the lesser the energy you will be using. And completeness means if there are a path between point A and point B, then you can find the path if the path exists. That means completeness. Incompleteness means if there are paths, you cannot find the path, then your algorithm or your method is incomplete. Okay, this I will show you later the example. Okay, path planning step. Basically, there are two steps in path planning. The first one is you have to represent the environment into configuration space. And secondly, you will use the graph search algorithm to find the path. Okay, so why we need path planning? Why we need path planning? Because we want to have a safe path from point A to point B to avoid any obstacles in between. And secondly, we want to have a shortest path because we want to save energy. And the third one is, I mentioned before, this is for autonomous system. You want to enhance the autonomy level of the robot. So basically, that's what I mean by the definition of path planning. How to get from, let me show the pointer. Okay, how to get from point A to point B. Okay, as human, we have brain and we can think. And sorry, let me change the pointer. Okay, maybe if we are given a task, or a human given task to find a path from point A to point B, we can simply draw it from, let's say, from here to here to here and to here. Okay, or we can go from here to here, then go straight away to the target point. Also, we can go from here. Okay, and there are many ways, many routes to go from point A to point B. If we are human, we try to avoid obstacles. Okay, this is path planning done by human. Okay, okay, now we want the robot to do the path planning. How are the robot going to do the path planning? The answer is we have to give instruction to the robot. We have to develop an algorithm for the robot to follow in order to get from point A to point B. Okay, let's say this is, for example, we use algorithm A. Okay, so now the robot is going from starting point to target point, from here to here. This one example. And secondly, this is algorithm B. Okay, so the robot also using different route from starting point to target point. And now we have algorithm C. The robot goes from starting point to target point. So basically you have many methods to go from point A to point B. But the problem is how fast your method is, how fast you calculate the path, how fast the robot calculate the path in order to be implemented in real-time application. Okay, so this is basically, I give some very brief discussion or very brief explanation about the established method in path planning. There are cell decomposition method, Voronoi diagram, potential fields method, visibility graph, probability log map, RRT or rapidly exploring random tree, or biologically inspired such as ACO and colony optimization, neural network, and so on. My focus will be on this method as this is basically my current research. Okay, let's go. Okay, now I will introduce you the graph search. There are many graph search algorithms out there, but I will focus on these three methods. The first one is best first search. Second one is A*, and the third one is Dijkstra. This one, this Dijkstra was mentioned by Professor Nabor just now. I still remember he mentioned about Dijkstra. Okay, what is best first search? Best first search is actually as a heuristic search algorithm which uses the distance from a current node with respect to the target point in order to find a path in graph. For example, you have a point here. Okay, we call a point A. Okay, and you have another point here, point B. Okay, and you have obstacles in between. Okay, how to get from A to B using this method? It's easy. So first you have to connect all the line here. 1, 2. Okay, so this is the obstacle. Okay. Okay, so you have we call node A. We have node B here. We have node C, and we have node D. Okay. So for example, H means the cost of the distance from point A to small a to capital B. Let's say I give here maybe, sorry, I cannot write. Okay, point D, let's say I make it maybe 11, I mean, the distance from D to B is 11. Maybe this is 7. From A to B, maybe, I don't know, maybe 20. Okay. Maybe this one 6. And this one, I don't know, maybe we put it 10. Okay. What you do is, using this algorithm, you will connect from point A to any point that are visible to A. For example, I connect from here to here and here to here. Okay. But I cannot see B because B is obstructed. Okay. So from A to D, from A, capital A to A is 10, and from capital A to D is 11. So the algorithm will choose the smallest one between the two. This is here. Here will be selected before it will go further. And secondly, the algorithm will start to calculate the shortest path from point small a to point B. For example, from here to B is, sorry, from here to here, okay? Sorry, from here to B. Okay, from okay, from here actually is 10, and from D is 11. So I told you before, the algorithm will select A, then it start from A to B, and from A to D. Okay, from A to B, the distance actually is 6 from B, and from D, the distance is 11. So it will select 6 here, okay? And again, from this point, it will connect to B here, where the distance is 6, and also B will connect to C, the distance is 7. So it will choose this one. So the path will be from A, capital A to small a, from A to B, and B to capital B. So this the algorithm if you are using the best first search. Okay, the next algorithm is Dijkstra. Dijkstra is different because Dijkstra, compared to best first search, let's say you have point A here, you have point B, sorry, and you have obstacle here. Again, you have small a, B, you have C and D. Okay, for Dijkstra, it's different because the cost actually is from the starting point. For example, A is 0 because the distance from itself, and B is 20. Okay. So for point A, small a, the distance here, if in here is 10, here also 10, because it is the distance from capital A to small a. So the difference between Dijkstra and the best first search is the way you define the cost or the distance. Okay, the next algorithm will be A star. A star actually is combination of Dijkstra and best first search. I think I don't have to explain further about this because I think we have a short time. I still have plenty of slides to be presented. Okay, next we go to the path planning method that are available in the literature. The first one is cell decomposition, where you have this is your search space. Okay, the search space. This is obstacle here. You see, this is obstacle. Okay, you have 3 obstacles, and you divide the search space into small cells. Okay, and the cells that are containing obstacle, you will decide it as the occupied cells. For example, this is occupied cell, okay? Okay, similarly to this obstacle, this is the obstacle. So this is actually the occupied cells. I mean, since part of the obstacle entered to that cell, so here also same. So basically you have this actually the obstacles area. This is important when you want to plan the path. Okay, so you will consider these nodes 1, nodes 2, nodes 3, and so on. Okay, but sometimes the cell size can be different. For example, this one you have a smaller cell size, okay? You have smaller cell size, while for this one you have a bigger cell size. Depends if you want to have a fast path planning. So you may want to consider the bigger cell size, the larger cell size. If you want to have accurate path planning, okay, so you may consider the small cell size. It will actually increase the resolution of the cell. Also, basically that we have programmed it using MATLAB, where the starting point is here. This is a starting point. Sorry, starting point is here, A. This is the target point, B. Okay, so we apply the concept of cell decomposition to find the path from here to here. So you see now the path is safe. Actually, the black one is the obstacles, and you see here, I mean that one actually is the area in the cell that are occupied by obstacles. So we consider the cell also part of the obstacles. Okay, this is a cell decomposition method to find the path. Next is actually Voronoi diagram. Voronoi diagram actually the safest path planning technique because the distance between the path to the nearest obstacle is equidistant. We call it same. Let's say, I mean, from here to the path here, and also from here to the path, actually same distance. Okay, but if you go back to cell decomposition, very close. Okay, but this one is very far. That's the difference between Voronoi diagram and cell decomposition. Okay, next I will go to next method. We call it potential field method. So potential field method is based on work by, I forgot the name, Osama Khatib. He actually the one who invented this method, where you have extractive potential. This is created by the target point. The target point will attract the robot, and actually this repulsive potential actually is created by obstacles and the starting point. Okay, so finally you have the net potential or the whole potential if after you combine this attractive and repulsive pulse. So this is we have programmed it in MATLAB as well. So from starting point to target point, this is using potential methods. And the next method is we call it probabilistic roadmap method. Okay, so this is actually a very easy method where you just sample points on the search space. Okay, if the point here, the red one, the red star, is in non-obstacle area, so it will be accepted. Okay, maybe before you start the algorithm, maybe you want to set the numbers of sampling you want to do. Maybe I want to have 1,000 sampling. Okay, 1,000 sampling on this area, and only samples that are not on the obstacle will be accepted. For example, you see all the sample here are outside the obstacles. The obstacles are in black. Okay, and finally we use a Dijkstra algorithm to find the path. Okay, from the starting point to target point. You can see the path here from here to here, and then here. So basically, this is the path created by the probability roadmap. Okay, but sometimes the path can be improved. For example, this path actually you can shortcut from here maybe to here, you know. So you can save a lot of energy if you make the path shorter. So then we develop as well what we call path pruning technique. Okay, this path pruning. Okay, the green one is the original path, and we make it shorter by implementing a path pruning technique. This will make the path optimal because I mentioned before there are 3 criteria for path planning: shortest path, time, and as well the completeness. So this method, probability roadmap, actually is complete as well as maybe I can say optimal, as well as the time also very short, depending on the numbers of the sample you choose. If you choose maybe 10,000, it might be slower. But if you choose maybe 1,000, maybe it faster in finding the path. Okay, next one is visibility graph. Okay, this is very simple. You have a starting point, a target point. First, you connect all the visible nodes. We call it mutually visible nodes. For example, from here to here. Okay, so these nodes are visible. This nodes is visible to these nodes. Similarly, these nodes are visible to this node. So we connect this two nodes. Let's say this node actually not visible to this. So you cannot connect it. Okay, you only connect the mutually visible nodes. And after you connect, you have connected all the lines, all the nodes using the visibility lines. Next is you have to use the search algorithm to find the path. For example, now the path is here to here and to here and as well to there. And here we call it waypoints. Waypoint, maybe this one waypoint 0, waypoint 1, waypoint 2, and waypoint 3. So we have 4 waypoints here. Okay, this is actually visibility graph if you are considering all the obstacles. Okay, this is, we also program it, we code it into MATLAB. So then finally we managed to find the path from this point to this point, but somehow the computation time is quite high because you see you have, because the algorithm needs to create all the lines here. So it takes time. And then the time actually is exponentially related to the number of obstacles. If you have more obstacles, then the time is more. Okay. So now, because of that, because I mentioned before, visibility graph is very good in finding optimal path. Optimal path means the shortest path from the starting point, target point. You cannot, I mean, any other method cannot find the shortest path as what visibility graph does. So now my research is focusing on this, but we try to reduce the time from, let's say this is maybe it takes 10 seconds to generate this path. We may reduce it to maybe less than 1 second and still producing the same path. Okay, real-time path planning. What does it mean? The robot operates in real-time environment that may change over time. This situation requires a path planning algorithm to quickly replan, because sometimes, you know, the environment is dynamic. You have a planned path, but somehow the path has to be replanned because your environment or obstacles change. Maybe there are some pop-up obstacles and so on. Okay, so this is actually the formula to determine how the number of the lines here. You see this one line. So the number of lines actually is 2 times n, and actually the number of nodes, you have 1, 2, 3, 4 nodes plus 1, and this is a formula. And for, as I mentioned before, visibility line or visibility graph, it can find the shortest path. The path is complete, but in terms of computation time, it is not good. So now we are focusing on this aspect. Okay, we want to improve this computation time of visibility graph. So this is actually the number of segments. That's what we call segment. Okay, of segments depending on the number of obstacles. For example, I have, let's say, 80 obstacles. It is only, I don't know, maybe 50,000, I think, segments. If you have 200 obstacles, the number of segments is, I think, maybe around 300,000, I think, something like that. So we want to make it linear. Instead of like this, we want to make the computation time to be like this. I mean, to be linear like this. Okay, so we don't want this. I mean, that as the number of obstacles increase, the time also not so high, you know, in terms of the computation time. Okay, so far we have proposed 3 algorithms based on visibility graph. The first one we call baseline oriented visibility line, or the acronym is B-level. And secondly, we have equilateral space-oriented visibility graph, or we call it ESOVG. And the last one actually is elliptical concave visibility graph, or ECOVG. This is basically the below-level algorithm. First, it starts with co-algorithm, where we create a baseline from starting point to target point, and we construct a set of nodes, NS, we call NS, from each node to each obstacle that lies on the baseline, and the extension including UStart and UTarget. The next step is we create a cost matrix CM from NS, and finally we find a local path U, which consists of these waypoints, U0 to UM, from the cost matrix using Dijkstra algorithm, where U0 is UStart and UM is the UTarget. This is basically the block diagram of the algorithm. And this is actually the demonstration of the algorithm. Okay. This is your environment. You have around, I think, 20 obstacles in total here. And first, according to algorithm, you have to create the baseline. I still have 15 minutes, okay? Create the baseline from here to here. And then you identify the obstacles that are hit by the line. For example, we have 14, obstacle 15 and 9. And next, we have to find out the obstacles that are overlap with the hit obstacle. For example, 14 is overlap with 8, 15 overlap with 11. Okay, so now the number of obstacles from 20, we managed to reduce it into only 5. Okay, from 20 into 5. So from this, we can reduce the computation time. Okay, so this is actually the visibility graph. Okay, the graph, and finally we find the path from here. This is actually the path. But one problem with the core algorithm is actually the path is not really safe, because if you see here, there is a collision there. I mean, the path collide with obstacle number 17 as well as obstacle number 20. So we have to improve this. How to improve? So we introduce another algorithm. We call it below-level. So if you see here, in step 4, there is a core. Core actually the main algorithm for below-level. Okay, so this algorithm, I think I don't have to read everyone. Okay, I mean, I don't have to read every line here because it may take time. So this is basically the flowchart of the algorithm. Okay. Okay, maybe I explain a little bit. First, the index you initialize to 0. Index means the number of the waypoint. This is waypoint 0, and waypoint 0, J is the P start. The starting point means here. Here is the P start. And later, what you do is you check whether your current waypoint is the P target. If the P target means you have arrived at the destination, then you stop. Okay. Otherwise, you have to give the value of U start to WJ, and U target is the P target, and you call core. After you call core, you get the path. You know U1 until UM. If UM is equal to 1, it will start to go to the next level, to the next step. Otherwise, it will again finding the path between the two waypoints. For example, here, this is actually U0, this is U1. Okay, U target. You start U target, you find out if any obstacles in between. If no, you proceed with between these two lines. Okay, if no obstacles, you proceed between this and 2. Okay, for example, from this line to this line, actually it hit this obstacle. What you do is, and the M number now is not 1 anymore. It is, sorry, it is 1 now. If no collision, M is 0. In this case, M is 0. For this case, M is 1. So M is 1, you have to do a special next step, which you have to do this again, okay? So finally, from this below-level, you will find a collision-free path. and the path is still optimal, I mean the shortest. And this is the comparison of using the conventional VG and the B-level. Even though it is exponential, but the time is much faster than VG. For example, if 100 obstacles in the environment, okay, the time taken to plan the path is 20 seconds, okay. But for B-level, you see the average one, the average in the red color, actually less than 1 second. So huge improvement made by B-level as compared to the conventional VG method. Okay, there are another method. B-level is the first one. Then actually we developed another algorithm still based on VG. We call it equilateral space-oriented visibility graph, or ESOVG. I think I don't have to read every line here. Maybe later on you can read it if you have the slide. Okay, basically we want to create this area. This area, actually, we call it the equilateral space. Okay, this is equilateral space. So this algorithm, mostly we want to create this space. Okay, based on your starting point, your target point, also the opening angle here. Okay, this is the opening angle here. Okay, then what is the purpose of this space? This space, actually, you want to limit the number of obstacles. Okay, for example, in this environment, you have starting point, your target point, you have a number of cycles here. So then you create the space. This is actually the space. Okay. And only obstacles in the space will be used for path planning. So now we can, I don't know, maybe around 50 obstacles in this area total. So now from 50, you manage to reduce number of obstacles to maybe 2, 4, 6, 7 obstacles only. Okay, so this actually will accelerate your computation time. So this is a comparison between VG and the ESOVG. Okay, for example, in 100 obstacles, it is around 20 seconds. And here, 100 obstacles, maybe, I don't know, 3 seconds, 4 seconds, something like that. So it is proven that ESOVG has improved hugely the computation time of the VG. And the last one, actually, we have elliptical concave visibility graph. This is basically the algorithm. It is similar to the ESOVG, but the problem is ESOVG, because the opening is very small, and it will have obstacle here. And actually, for ESOVG, we develop further this algorithm. We call it iterative ESOVG, or we call IESOVG. Okay. So from here actually to here, we add I mean iterative. If let's say in this area you cannot find path, you will increase the size of the area. Okay, I don't show it here. You will increase it, you make it bigger, something like this. Okay. By changing the opening angle, then again you calculate the path. If you couldn't find it, you can find the path. Again, you increase it. This is done iteratively until you find the path. Okay. The problem is for this method is you have to do many iterations, and actually it takes time. Okay, it will increase your computation time. So that's not good. So we improve this algorithm by introducing another method, what we call as the ECOVG, elliptical concave visibility graph. So what does it mean? It is actually, you want to create this area, same, okay, this area. And also you want to decide the width of the area. This one actually the starting point, the target point. So from this point, 1 point, 2 points, 3 and 4 points, you can create this, what we call it, elliptical concave area. Okay. So from this area, actually it is better. I mean, this is an environment where you have around 50 obstacles, and you manage to reduce the number of obstacles by using this method. Okay, I think maybe then around 20 obstacles here, and finally you could find the path from here. Okay, so this is actually the comparison between the IESO VG and the Eco VG, and we found that the performance is same. Okay, not really different. For example, 300 obstacles, it is around 6 seconds here using IESO VG, while using the IESO VG, the time also 6 seconds. Okay, I think that's all my presentation. Sorry, I cannot finish 45 minutes, only 40 minutes for my presentation. Maybe I open for Q&A after this, if you have, please.
How do you finish, Professor Rosli?
Yeah, I finished already. Thank you very much. Yeah, I think finished earlier.
Thank you very much.
Your plan, yeah.
Now, if anyone any questions, please. I'm sure Prof. Rosli will answer your question. We have only 5 minutes. Please raise your hand. Yes. Please, Gilang. Mr. Gilang.
Okay. Hello. Can you hear me, sir?
Yes, I can
please
hear you.
mention your name and your affiliation.
Okay. Thank you for the opportunity. My question is about the resampling path when there is a pop-up obstacle that lie on the planned path, which it will update all the obstacle data. And my question is the resample process include the past obstacle or it's resample only from its current position to the target? And my second question is how we can consider the dimension of the vehicle in this algorithm. Correct me if I'm wrong, I didn't see any input about vehicle dimension for this algorithm. Thank you.
Okay, thank you very much for the question. I think there are two questions. The first one is whether you can start planning the path from the current point. Yes, exactly. That's why that's the main reason why we developed this algorithm. Because if we use the conventional algorithm, I mean the VG algorithm is very slow. I mean, you might not be able to plan the path. You know, as your, let's say, robot is moving, you cannot, because before you finish planning the path, the robot might hit any obstacle, might hit any obstacles. So that's why we need a very short time to plan the path from the current position to avoid obstacles. I think it was, actually I have the simulation, but I didn't show here. The simulation is very nice because in that simulation using MATLAB, we have actually pop-up obstacles, you know. I don't know, maybe I can give you one example here. Okay, for example, let's say your robot or your UAV, you can say anything. Moving from here, sorry. Okay, I hope you can see my pen here. Moving from here to here, and suddenly there is an obstacle here. Okay? Suddenly there is a pop-up obstacle here, and the algorithm is able to avoid it. Maybe it'll find another path, something like this. You know what I mean?
Okay.
So it will avoid it because it's very fast. Maybe it'll take them less than one second, maybe, or less than 0.5 second. But you must make sure that you are able to plan the path from the moment this obstacle appear, okay, to the border here. That's why your robot needs some sensors to determine how far the obstacles from your robot.
Okay.
Can you understand me? Sorry, maybe my English not so good.
Yeah, it's clear, sir. I can understand what you
okay,
say.
What's the second question?
About how we can consider the dimension of the vehicle in this algorithm.
Okay, I mentioned before, actually we consider configuration space. in configuration space, we assume the robot is a point, you know. But okay, by increasing the size of obstacles. For example, the robot initially has this size. I don't know, maybe the radius, maybe 1 meter, I don't know. The radius of obstacle 1 meter. So you reduce the size of the obstacle into a point. Okay, the size of a point, but you increase the size of all the obstacle here. You know what I mean?
Yeah.
So now you have make the problem easier.
Okay.
I mean, the dimension of obstacle still considered. Okay, by reducing it to a point while you enlarging, you make the size of the obstacle bigger. Same, right? That's why we call it configuration space. I mentioned just now here.
So it's almost like a potential field.
Potential field, yes, definitely. Yeah. Maybe you are interested in path planning. Maybe you can contact me later.
Yeah, thank you, sir.
Yeah, welcome.
Or maybe can I ask one more question?
No problem. Yes, please go ahead.
Okay, please.
Well, about the real-time sensor we need for this algorithm, can we use a low speed sampling time sensor for this algorithm? For example, a low FPS camera, such 30 FPS camera maybe?
Okay, normally the sensor we use is ultrasonic if you have a robot, I mean, which is not fast speed, ultrasonic, okay? The ultrasonic, I think the range is not so very long, maybe 1 meters, maybe 30 cm to 1 meters. But normally we use LiDAR. But LiDAR is very expensive, yeah, to scan the obstacles.
Okay.
Okay, maybe that's all, sir. Thank you for
You're welcome.
Answer.
Thank you for the questions.
Okay.
Professor Roji, we
Yes.
have 1 minute. Let me ask you more.
No worries, no problem.
So, actually, I'm not in robotic field, but just please. My question is about obstacles. I know in one of the view graphs, nodes are created between starting point and target point, right? And then these nodes are created from the corner of the obstacles. So the question is, what happened if the obstacle has no corners, like the shapes are round or quarter circle? What happened?
Oh, sorry, pardon. Maybe you can ask again. I cannot listen
So,
clearly. Please.
The nodes are created between start point and target point. And
the nodes, okay, yeah.
From the corner of each obstacle.
Yes, you're right.
What happens if obstacle have no corner? It's like
Okay, I understand.
circle shapes.
Okay, basically our algorithm is based on the vertices, or we call it nodes. Okay, and it depends on the nodes to create the line. If you remember what I explained before. But if you have like circle has no corner, right?
Yeah.
What you do is you sample some nodes along the perimeter of the circles. But it depends. If you put too much nodes, it will slow down your time. Okay. So you must select the adequate number or the sufficient number of the nodes along the obstacles perimeter, so that you can still have fast calculation.
Okay, thank you very much.
Yeah, normally in our research we consider polygonal obstacles. I mean, it has corners, you know. Normally, if you use like round obstacles, we use they call it algorithm. There's an algorithm we call it Dubin path. Maybe you have heard before Dubin path. For those who have done research in robotic path planning, maybe you have heard about Dubin path. Dubin path is very efficient in path planning for round obstacles.
Okay, thank you very much for your explanations.
No problem.
So, ladies and gentlemen, for 2 hours, we got very interesting topics from our honorable keynote speakers, Professor Munabigi is still here, and Professor Rosli. Actually, this year we already planned a visit UTSM and Okayama University, but we already postponed to during this COVID-19 pandemic. We hope next year we can visit your universities. So again, ladies and gentlemen, may I thank you, very active participant in this first keynote session in this conference, and then please give applause to our keynote speakers, Prof. Munabigi and Prof. Rosli. Hopefully, all of us, in good health, safely, and during pandemic. So, thank you. Now, for the second keynote session, I'll pass to Ms. Maya as moderator.
All right. Thank you, Dr. Ervan. Good morning, ladies and gentlemen. Allow me to introduce myself. My name is Maya. I am from Department of Business Administration of State Polytechnic of Malang, and I am your moderator for the third keynote sessions. In this session, we will have three speakers. The first is Mr. Anang Yahmadi of PT PLN, or National Electrical Company of Indonesia. The second, we have Dr. Anggit Murdani of State Polytechnic of Malang. And the third, we have Mr. Nana Sutikna, which is a practitioner in oil and gas industries. Unlike the previous keynote session, in this session, question and answer is devoted at the end of the presentation. So after all the three presenters have delivered the material, and then we will open a question and answer session. Okay, without further ado, I am going to invite our first keynote presenter, Mr. Anang Yahmadi. How are you, Pak Anang?
I'm good, thanks, Maya.
Okay, thank you, Bapak. Okay, before we listen to presentation from Mr. Anang Yahmadi, allow me to read a brief biography of our first presenter. So, born in Mojokerto in 1968, Mr. Anang Yahmadi attained his undergraduate degree in Water Resources Engineering from Brawijaya University, Malang in 1992. After that, he received master's degree in engineering science on energy studies from the University of Melbourne, Victoria, Australia in 2004. He has been an employee of PT PLN since 1994. His working experiences are as a hydraulic engineer and hydrologist of hydropower plant projects, support engineer for thermal power plant projects, and then an officer for planning and procurement of gas and geothermal system. He also has been assigned as senior manager for geothermal in 2011, general manager for power plant project in 2014, head of project management office division in 2017. Since 2019, he was the executive vice president of strategic procurement division, which is responsible for supporting the BOD for investment decision dealing with technical and financial feasibility, strategic procurement, technology choice, and local content policy, as well as vendor management. Finally, he is also the member of Executive Committee for Indonesian Commission on Large Dam and members of Dams Safety Committee. Okay, without further ado, I am going to give the floor to Mr. Anang Yahmadi. The time is yours.
Thank you, Mbak Maya. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, Bapak Ibu sekalian. Puji syukur kepada Allah karena kita bisa hadir pagi ini. First of all, I'm thanks to the organizer. There is Pak Indrano Sirajuddin as the chairman, and then Pak Awan Setiawan as I think the director of the Polytechnic Negeri Malang. Thank you for inviting me to join in this very special event. It is a very honor for me, and it is very, I'm very happy because I will come back to the academic situation as I enjoy the first keynote speaker. It is very academic and very science. Already a long time I'm not involved like this, so I think in this the next session we will hear about how the practitioner see the new era of 4.0 era, and then how we can connect between the academic and the real life situation, what happened in the world of business and everything. So today I will talk about what is happening in the PLN's procurement when we deal with the digital transformation. I think this already explained by the moderator, and this is the agenda. I will try to a bit introduce the PLN, and then what actually challenge and strategy, and then overview a bit about transformation program in PLN, and then a bit also about digitalization of procurement, and also I will sharing about what happened already developed in PLN procurement planning. So by this agenda, I want to share what the PLN situation to the audience. I believe that the audiences mostly come from the academic world. So I think it is good to get the feedback from the practitioner like me or from PLN to think about how we can participate in the real world. Normally, when we in the academic world, we always think about the ideal situation. We don't have any much constraint. I mean, we can focus on how we calculate, how we communicate with the same academic people. But when we come to the real world, then there are some more than ideal life actually. We are also dealing with the legal. We are also dealing with the policy, and also about about the commercial. Finally, we always talk about how we can live, how we can struggle, how we can survive in the current situation. So this is the objective of I present here. So I hope it is beneficial for the audience. So in the beginning, I want to introduce a bit the PLN. We know that PLN is the very big enterprise, and also very, because of the big company, then also have so many complex problems. Until now, PLN is still owned by the government of Indonesia 100%. So we always communicate with ministries. We always regulated with the regulation. It is also still like this for a long time. And then we have two obligations that always pair. One is a company that should produce a benefit, and then on the other side, we should also, as a government agent, to support the government to develop the country. And then in terms of the utilities, we manage the complete national electricity utilities from the beginning. I mean, from the how we provide the energy primaire until how we sell the electricity to the people. So this is the complete. It is, if compared with IPPs or independent power producer, they only, for example, provide the electricity from generation. Maybe also by the primary energy, but PLN also include the transmission and also distribution, and also how to sell or retail the electricity. Of course, because of this, we have a complex business process, how we deal with this one, and then also the supply chains. I mean, how we provide from the procurement until we can operate the asset or the equipment. And the revenues, of course, because we a big company, so I think we now reach almost 300 trillions per year. And then the capex and opex is almost 360 trillions, almost 1 trillion a day. It is very big number, but also a complex, of course, and very also challenge situation in any case or any segment of business. The coverage, of course, we coverage the national from the Sumatra until the Papua, and then also from the cities and also the village. The assets now, I think we are the number one. It is a 1,600 trillion. It is, and then followed by the BRI, Mandiri, and also Pertamina. And then about the customer, we have a 77 million customer. It's also very challenging situation. And as compared to the Southeast, I think we are also the biggest in terms of asset and customers. With the one edge, the asset is 1.9, and then the customer is 76. It is in the 2018. So I think this is the significant value, and then we can optimize this as a business in the future. So I think it is information for the academic or for the technology provider. And then I think this about trend. So we now in the trend of industrial revolution. I believe that every company will think about this, and PLN also, how we deal with the fourth industrial revolution. This is the 4.0 situation. We don't want to lose like what happened in BlackBerry or Nokia, and then also what happened in like Petrochina and also General Electric, yeah. But we understand that most the large enterprises in the software and also application business. Then this is the already PLN thing that now we are facing the disruptive technology that can, it is a challenge or can deeply impact to the PLN business. We categorize as the carbonization, generalization, and digitalization. So I think it is also feedback to the academic that please also think about this, that now we think or we review that this technology will impact very much in the future. Yeah, now and in future. About energy efficiency, of course, now everybody think about this one, how to manage this energy, how to produce the equipment with the very efficient energy usage. And then electric vehicle, it is also growing and growing. Even it does take time, but I believe that we don't know when the boom is come. Maybe the next 10 years, or maybe the next 20 years, or maybe the next 5 years, more electric vehicle will come. And then renewable energy, it is also the global aspiration that in the future, the green will take some more playing more significant roles. And then energy storage, yeah, of course, the battery, it is also that will come larger and larger, maybe to provide the home system or maybe the car and everything. And then carbon capture, I think also that because of the carbonization policy, then we need to manage our coal power plant that takes 60% of the PLN generation. It is also a challenge how to manage the carbon from the coal power plant. The green hydrogen, it is also, and then distributed generation, microgrid, energy service. It is also will take more role in the future, and also the digitalization that we discussed today. I tried to share a bit about the digitalization in this discussion. But now the COVID-19 is come. It is a very significant impact for the whole world, I think, also for the PLN. Because of this one, PLN will review the long-term program, how we have a plan to provide the expansion of the generation, expansion of transmission, the estimation of the growth of the electricity, the projection of the revenue and everything. So it's a very big or significant impact because of this one. So we identify the challenge, the PLN challenge for this one. That I believe that all of the Indonesian are connected to the electricity and always demand to have the good standard of service. It is already understand by PLN how to provide the good service for this one. And then we also impact by the exchange rate. The fluctuation of exchange rate also deep impact to the PLN policy or PLN decision. That's why we need to have a system to support how to make a very fast decision for this one, and also how to provide extra spending for this one. And then the rest is about the tariff that always still defined by the government, and then how to manage the very large number of customers across the 6,000 island. It is also the challenge. And then how to make integration of so many assets and also so many business. And then about how to increase the innovation in the digital capability. And then of course we also think about the human resource, the organization, how to provide this one, how to make we are ready to come to to facing this challenge. And also blackout. That is I like the disaster. I mean, everybody, when there's a blackout, then PLN is the kambing hitam, yeah, the blackout. I mean, always that the PLN is the blackout, even it is happening anywhere. So this is the strategy. I mean, we will improve in the business aspect, also technology and people. In the business, I think we will consolidate and harmonize expense, and then how we get access to the market intelligence, because I think we PLN and Pertamina is about 1/3 of the budget in this country. So many vendors, so many manufacturers connect to the PLN business. So it is very important. And then transparency, it is one of the I think the era now. Everything should transparent, should accountable, should fair. It is also one of the business development. And then how to improve the speed and accuracy. And then for technology, this is the important feedback to the academic, that please support this, how we increase the digital. I mean, how we deal with artificial intelligence, how we meet the digital forecast, management, estimator. I think because of the fluctuating change situation of the world, then we need the modern or the digital application. And these are related to the integration and also standardized. And then for the people, I think this standard, how we minimize, how we review the organization, how we increase the capacity of the human resource, and how to change the mindset, and this of course should be provided. So it is what happened in the PLN. So now we think we have a dream that we will the number one customer choice in Southeast in 2040. This is the dream of PLN. How we can go with this one, and then we have 4 main program: green, lean, innovative, and customer focus. So in green, we will increase or boost the renewable energy. Lean, we make a reliable and low-cost electricity provider. Innovative, growth simulation through innovative business model and service, and also customer focus is how providing satisfaction to the customer, to the world-class service. I hope we reach this in 2024. This is the initiative or the breakthrough that maybe come to the customer. Maybe you will feel this one, how we provide the billing optimization, how the customer can pay very easily and can good access when there is a problem regarding the electricity at home because of the blackout, because of the problem in connecting and everything. And then with new electric era, captive power, still there are some captive power that we can manage or to access to PLN, and then electric vehicle. I think this is the whole of the transformation. And I put the bold on digital procurement and digital power plant. This is that again, I hope always in our mind that now we come to the digital world. We now build how we make everything in digital. So we start in the procurement and also in the power plant. It is a bit on the concept of digital procurement that now we built now. I think now it's in the process of 50 or 60%. That we start with market intelligence. It is I think this development involve the science and engineering from the academic, yeah, because we deal with the program, we deal with the IT technology, we build the thing about the knowledge of marketing and everything. So like I said before, that because PLN spent about 360 trillion per year, so we need to have a system. Who should PLN buy from? I mean, we know that there are so many providers in the world, in the international and local, and then who we should buy? I mean, we should find the best provider that give the good service to PLN, good price, good quality, and also good delivery. I think this is the point. So in the market intelligence, we have the system that connected to the website, and then we have a machine to always monitor what happened in the web board, and then we can always monitor which vendor or which company have a very good reputation and very bad reputation. Then we will find in the real time or in the on time what vendor or what company we need to buy. And then we have a system called electronic DPT. This is what the system to legally to formalize the client or the list of vendor that always in the PLN database to make sure that we buy to the right company from the point of view, legal and also the commercial and technical. And then we continue with demand forecast. It is very important because when we will buy very huge number of equipment, like we should buy the cable for the power, and then the conductor, the isolator, also the material distribution, material of transmission, maybe also the component of the power plant. We should manage our cash very well. So we can forecast in the next year what kind of equipment we will buy, how many of the equipment we should buy. So we have a system for this one, the digital system for this one, to manage things based on the database of the spend money of the PLN, and then we will have a projection what happen in the future, and we will define how much the demand. And then we come to spend analysis. It is very interesting model, and then we know what kind of spend actually PLN already use. Like what is the major spending money PLN, and then what is who is the client that have the biggest business with PLN, and then many things of this year or this application, and then we know how to make a decision based on the spend analysis, and then how we make a strategy to buy, and then what kind of saving we can get from the strategy. It is very interesting. And then cost estimation also. It is when we doing this manually, we always have a constraint regarding the accuracy, and then manual or mistake because of the human error, the repetition of the error and everything. So by this system, we can avoid these flaws, and then we can get the data more accurate, and we can have a better position when we negotiate with the vendor. It is the point for cost estimation. And then we come to the tender, how we negotiate based on our data. It is also based on the information that come from the previous model, and we know what kind of the cost, what the structure, and when we negotiate with the vendor, we have valid data to speak with the vendor. So and then we continue with the distribution. I think PLN now we also build the marketplace like Tokopedia or like maybe and Lazada something. So for the equipment that already defined the specification, we'll put in the marketplace, so we can choose which one is the best price, and also the availability, how much they provide the equipment. It is the marketplace, and then also the inventory information is still not yet developed. I think it's in the future we will develop this one. So what is the benefit from the digital procurement? Based on this one, we believe that this will transform the procurement process end to end. It is a breakthrough digital business transformation using proven tools to enable faster, more precisely, and safer implementation. Yeah, this is the point. And then saving. We got the saving. I believe we can get 8 to 20% because of this one. It is a big, if we compare with the spend, our spend in the year. Yeah? And then time efficient and quality, increase work productivity through working time efficient and quality improvement with the digital application. Yeah, and then human capability development we also improve our human resource to support this one. So when there is a new improvement, also a new modification we can do by ourselves. And then we have an integrated platform. We try to build any kind of application in our company to integrate it. We have several application, then we will make it integrated and also user friendly. And then inline and support government program. This is the adaptation of digital technologies like artificial intelligence and big data analysis. This is in line with our revolution industry of 4.0. And of course, we always support the government to making Indonesia 4.0. So I think this is the last slide. This is our application in the procurement planning in my division, that we also have engineering center, and then we have also a management center for engineering procurement. In this application, we can manage, we can monitor the performance of the power plant, because the power plant also developed by the digital power plant, yeah. Then any data digital can provide in here. And then we also have the ATKDN. This is related to local content, because this is support the government policy to always increase the local content. My division also have responsibility to coordinate this one. So we provide the system to monitor and to have a program how to increase the local content. And then regarding the procurement document, we already have electronic standard document. So I believe that when we procure the generation, transmission, or substation, we already have a standard and electronic standard document. So it's a very countable and yeah, it's very good document, I think. And also we have IDPT. I think this is from me. Thank you very much. I hope this can give a brief understanding what happened in one of the large company in Indonesia and give a big picture. Maybe you have an idea how to support this one, how to connect to the big company like PLN. I believe that like in Pertamina, in other company also have maybe similar situation when we deal with the technology and development information today. Thank you very much, and I give back the time to the Humaya. Thank you very much.
Okay, thank you very much, Mr. Anang Yahmadi, for such insightful presentation. Before we proceed to our fourth keynote speaker, Dr. Anggit Murdani, one quick announcement from the committee that link to the conference attendance list is available on chat box. So please take a look at the Zoom chat box in order to access our attendance list. All right, and then we are going to move on to our fourth keynote speaker, Dr. Anggit Murdani. How are you, Dr. Anggit Murdani?
Okay, thank you. Good. And how are you?
Okay, I'm good, thank you, Bapak. All right, before we listen to Dr. Anggit Murdani's presentation, allow me to read a short CV of our fourth keynote speaker. Dr. Anggit Murdani received his bachelor degree in mechanical engineering from University of Brawijaya, Indonesia in 1995. And then he pursued study in Japan and received master degree in mechanical systems engineering and doctorate degree in materials, structural, and energy engineering from the University of Ryukyus in 2006 and 2009, respectively. In terms of his working experience, he was an engineering staff at Samsung Electronics Indonesia .co.ltd in Surabaya between 1995 and 1997, and at Matsushita Lighting Indonesia in Pasuruan between 1997 and 1999. At the moment, he is a senior lecturer at the Department of Mechanical Engineering, State Polytechnic of Malang, Indonesia. Besides that, he is also the Vice Director for Student Affairs at the same institution. In 2015, he received short-term fellowship from Japan Student Service Association. More importantly, his research area includes fatigue behavior of materials, strength of materials, fracture mechanics, and composite materials. At last, he is also a reviewer for journals of Sage Publisher and Omics International. All right, ladies and gentlemen, please welcome our fourth keynote speaker, Dr. Anggit Murdani. Time is yours.
Okay, thank you, moderator. Can you hear my voice?
Yes, very clear.
Okay,
Loud.
thank you. So I will start to share my presentation. Okay.
Please. Yes.
Can you see it?
Yes. Yes, sir.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable the Director of Polytechnic di Malang and all Vice Director, also all the keynote speaker, Professor Funabiki, Professor Rosli, and Mr. Anang, and Mr. Nana Stiksna. And I'm very happy now to get the opportunity to join this conference for the second time, because last year I also joined the SNGBR, and this time also the committee gave the opportunity for me to join the SNGBR also. But this time SNGBR is collaborative with ATASEC, so there will be many or more participants join in this conference. Okay, actually maybe not many things to present now, but let me to try to just to remind, maybe not the new one, but this just to remind us, or for our college, especially in mechanical or related field, because for the previous keynote speakers, the topic is around IT, so it's very far. So I try to make a different situation. So this is the most important of this topic now. I mean, that's when we talk about COVID-19, people talk about immunity. So let make us happy, so and healthy by doing sport and leisure. So we just try to get a stronger immunity to survive during this pandemic of COVID-19. So this photographs is even over the last year in Bali. So I think many people is attracted to join this kind of event. So many places in Indonesia, and then also, of course, in Malang is many events like this. So maybe Professor Funabiki would like to join us next year again in Polytechnic Negeri Malang, and then we can make this kind of event. So we hope COVID-19 will disappear sooner, so we can enjoy this life without some kind of a heavy.
Hopefully, sir.
Yeah. Okay. Okay. And this is maybe many people dream about this, but for me it's not affordable, too expensive. It costs around maybe, I don't know, maybe around 100 million rupiah, or in yen maybe around 80,000 or 800,000 yen. Yes, 800,000 yen. Hachijumangeng, yeah. So it's very expensive. So maybe it's not affordable for me. But what to see on this bike is the material used for the bike frame. This use composite material. This, of course, it used carbon material. So it's what we want to talk about. It's not just the material itself, but what is the problem when we are developing the composite material, especially if we use natural fiber. So natural fiber is in Indonesia especially is abundantly available. So for us, it's easy to get abundant natural fiber to be or to make a kind of composite. Okay, first, of course, I also to be a representative of this institution, so I also to remind our colleges to see about the research priority, national research priority. It was presented by the Minister of Research and Technology of the Republic of Indonesia, Mr. Brojonegoro, right? Okay, and in this chart or in this picture, we can see that in one side is maybe I want to use pointer. So at one side, we see the new and renewable energy. I'm sorry, this is in Indonesia. This is the Ministry of Research and Technology material. So I just take this material. And in this, the other side, we see the advanced material. So what we talk about is about our Ministry of Research is provide us to facilitate, to develop, or to make a research in this field, in energy, new energy and renewable energy, also in advanced material. So it's related with one of our project here. Later I will show that I have also a small project. Even a small project, it's just effort for us to achieve all the policy from the Minister of Research and Technology. Okay, I think this is not a new one. For to know that in my presentation, there is no detail because I want to avoid kind of copyright mistake or something else like that. So I'm sure everybody know about this, and it will be no problem for easily to understand this topic. So first, to remind us, it's a composite consists of matrix and reinforcement. And reinforcement can be one or single or more than one, means that multiple reinforcement. So the reinforcement can be any form, at least as fiber, flake, or any other kind of form of reinforcement. So it's just to remind. So in the short term, or in the short way, we can say that the composite, the purpose is to get the benefit of the two. The benefit of the two means the two is between matrix and reinforcement. If the reinforcement is more than one, so it means that the benefit of maybe the 3 or the 4 and so on. So the benefit should consider the application. So the application depends on our focus. So later we can see that. Our problem now is many things about the environment issue. So one of the example is the composite waste. A composite waste is many source of waste. So we can say that the most, this is not only one, this is not the only one source of waste. And the most, the largest amount of waste is yielded by the wind turbines. Wind turbines mean, of course, a large scale of wind turbines. So it is estimated from a study here is in 2034, it will be 600 tons of waste solely from wind turbines. It's a very severe problem, I think. And in many articles or in magazines, we can say that they agree that this amount of waste will be a big problem in the future. Another source is from automotive, or maybe another source of industrial products that can be waste. So our effort is reducing the environmental impact, is try to increase the percentage of biodegradable material or decrease non-biodegradable materials. These two ways of efforts can be done simultaneously or in one side. So whatever we can do, for example, if we just say a matrix and reinforcement, if we can change in one component, for example, the reinforcement, so we can use a biodegradable reinforcement, even the matrix is not or non-biodegradable. So we can say we can do with the one way or two ways. Okay, I think this is not also the new one. Just to remind also, because in our field, especially in mechanical engineering, we are familiar with this topic. So just to remind us, which we have kind of a matrix for our composite. And then we focus on biodegradable polymer. Actually, there are more detailed explanation about this, because we have a very short time, and then we should take a look what is the tale of a synthetic polymer and natural polymer. I think everybody in the field is very familiar about this. But to remind us, we have to take a look that we can use synthetic and natural in our previous slide that we have to reduce environmental impact. Now we see the biodegradable material. If we use natural fiber, there's also many kind of natural fiber. So we can say that in Indonesia, maybe one of the popular natural fiber is jute, or in our local or Indonesian language we call koni. So it will be the most abundant fiber, natural fiber, I mean, available in Indonesia. This is actually not in Indonesia, also in other countries like Bangladesh, even like India, also available abundantly. Okay. Okay. It's not to make a kind of reference, just to see in general sight the publication trends in composite. In any kind of composite, it's not just a polymer composite, but also in metallic composite, in any kind of composite. We have, we can see this chart that in 2019, and we cannot say in 2020 final, because still now in August. So in 2019, we see that the number of a publication in the year of 2019 in the composite topic is around 9,000, although more than 9,000 is so many. It's so many. And we take a look in this next chart. The next chart is, we can see a more specific topic. In all topic, of course, related to composite material. So detailed keywords to be a natural fiber. We can see this, the trend is increasingly, rapidly increasing. That we can see the number of application also for the top three. We just take the three kind of fibers, natural fibers, I mean, jute, hemp, and flax. So we can see here, there are three natural fiber with the trend of publication, a number of publication for the last 10 years, from the 2011 to 2020. So actually, the problem is not just the natural fiber itself, because if we talk about natural fiber, it's very complicated. We talk about just how we can use. We do not talk about how we can harvest it, or maybe how to plant. It isn't out of my out of our field. So we just talk how to use it. And another topic is a very challenging, is a micromechanics in the composite material. It's very few number of research concerned to the micromechanics, because in the problem of a natural fiber is we see as the main problem in natural fiber is anisotropic properties. And isotropic means is not homogeneous in easy way to say, and not homogeneous. So in the same type of fiber, I mean that, for example, jute, even in the same origin, for example, in the local jute for local plants, even each fiber has different properties, each fiber. So it means that it's difficult to get generalized properties for the composite material reinforced by natural fiber. The next problem is physical properties limitation. This is physical properties. It's like related to the temperature, humidity, and so on. It is that at least these problems are at least. Another problem, for example, maybe about related to health, maybe like allergy or something like that. Allergy, yeah. Because natural fiber, some type of natural fiber affect this human skin to have a kind of like irritant. Yeah. Okay. What is our effort to improve natural fiber reinforced composite properties? To improve the natural fiber reinforced composite material, some ways taken by many researchers. Yes, it is a very familiar or a very popular way. Yeah, first is compatibilization, because between matrix and reinforcement, it's some kind of problem to get the interface bonding. So this is one example of the problem. So many things done by researchers to improve the interface bonding between the matrix and reinforcement. Even a physical treatment or chemical treatments or any treatments. So the second is optimizing fiber architecture or design, because the form of the fiber configuration can be any configuration, like unidirectional or cross or weave, yeah, many form. So, and the next one is developing manufacturing method. And in the next, we will see the this detail of this one. I think we have to say that the compatibilization is treatment is can be categorized as physical treatment and chemical treatment. Also, another effort is studying about mechanics modeling in the macro and micro. In macro, usually called structural modeling, and the micro is usually we call micro mechanics. All can be done both in computational or analytical. And manufacturing method also. Recently, a new method, even not very new, but relatively new, is an additive manufacturing. Now we use very popular called 3D printing, and very popular now, and even a very cheap equipment or machine for 3D printing. So I think the last is I will show our project is to develop the substitution of the material for plates for wind turbine. So the purpose of this project is to use natural fiber as a reinforcement for plates for wind turbine. So as we can see here, in a single fiber properties is very different. Like a human, every human has their unique properties. So natural fiber is also like that. Even in a every single fiber has their unique properties. So it's very difficult to make generalized properties of the composite material reinforced by natural fiber. And another properties related to the performance of the plate for wind turbine is the performance for a cyclic loading. So in the cyclic loading, we can also evaluate how the composite can withstand with a cyclic loading in the certain number of cycles. The next properties is stiffness. We can use the vibration properties. So of course, it related to stiffness. If the plate is vibrate or is less stiffer, so can make a vibration, larger vibration. So this is the problem. So we have to design the properties of the plates stiffer or a less vibration effect. Also, in the form of discontinuities. Discontinuities can be form of a connection or kind of joining. So we still have to consider this. For example, how to put the rotor blade on the body is we use the like bolt and nuts also. So in that case, there is discontinuities. We can also we have to analyze or to study about the effect of discontinuities on the stress. So we have to make a stress analysis in this discontinuities. This is an example of the process we're using a vacuum infusion process. So the fiber and the resin are made to be a composite and with a vacuum infusion process. This is the example of our product that we use or make from the composite reinforced by natural fiber. In this case, we use jute or goni in Indonesian, goni, as the reinforcement. So we will make a performance testing for the wind turbine blade. And even that in this small scale, but we hope that this blade can be more and more feasibility and can be substitute the current material. So the challenges in natural fiber reinforced composite materials, at least these three, is the better physical and mechanical properties. As we see, that it start from the problem that the physical element, that's the natural fiber has the anisotropic property. So the next is the advanced manufacturing process. Actually, the advanced manufacturing process related to the third one is the lower cost. So it depends on the progress or the technological consideration. So sometimes we talk about the technology, sometimes we talk about the cost. So which one is more economically? So I think that's all my presentation. So we can proceed to the next discussion. Thank you very much.
Okay, thank you, Dr. Anggit Murdani, for such fruitful presentation. To save the time, let's move on to our fifth keynote speaker, which is Mr. Nana Sutikna. Mr. Nana Sutikna, how are you, Mr. Nana Sutikna?
Fine, thank you, Maya.
Okay, before I give the floor to our fifth keynote presenter, Mr. Nana Sutikna, allow me to read a brief curriculum vitae of our fifth presenter. So Mr. Nana Sutikna is a seasoned practitioner in oil and gas industry. He attained his bachelor degree in mechanical engineering from Bandung Institute of Technology, Indonesia, or ITB. He has 27 years of experience in oil and gas industry. Starting from August 2008 until today, he is the QA and QC coordinator in Kangean Energy Indonesia. Because Mr. Nana is ready with his presentation, I am going to give the floor to Mr. Nana Sutikna. The time is yours.
Okay, thank you, Maya. Okay, thank you. Maybe before I proceed with my presentation, I would like to make just a bit correction, because right now I'm already retired from the oil and gas industry since 2018. So right now I'm no longer working for any oil company, but sometimes I go and discuss, and also I help my former friends to solve anything with regard with the QA or QC, especially quality control in oil and gas company in oil gas. Let me share my presentation material.
Thank you for the correction, Mr.
Okay,
Anas.
you're welcome. You're welcome. Well, firstly, I would like to thanks to the committee, to the organizer, to who has given me the opportunity to share my not really knowledge, but this is just the experience. And after I'm having around 30 years working experience in oil and gas, so in my retirement, I would like to share all what I have gained as an experience to everybody, because I want that sometime what my experience will be useful and by others who will proceed the working in oil and gas, especially in QA/QC. My title for this presentation is QA/QC in oil and gas industry, the implementation of Industry 4.0 for QA/QC in oil and gas industry, the opportunity and challenge. This is my outline. Firstly, I would like to explain the basic concept of quality assurance and quality control. And then secondly, I would like to explain about the QA/QC in oil and gas itself. And then I would like to give a brief about the Industry 4.0 in QA/QC in oil and gas. And then some sample of application of the industrial 4.0 technology in the oil and gas industry. And then we will conclude with the conclusion. Now let's move on to the basic concept of quality assurance and quality control. Firstly, what is the quality management system? The quality management system is the aspect of management system. So this is about the management system that's setting out the quality practices, the quality policies and procedure that demonstrate the compliance with the corporate system requirement. For example, the quality management system is ISO quality standard, which is internationally adopted by any company in the world. Then what is the principle of the quality management system? Firstly, the first principle is the customer focus. So the customer for us for the quality management system, the customer is our king. So we serve the customer as much as possible. The second thing is a leadership. So the quality is managed by the management. So when the quality is bad, the one who is going to be blamed is the management. How the management manage the organizations until the quality is not satisfied. And then the third one is the involvement of people. Even the leaders or the leadership is has the focal role of the quality, but everybody in the organization is involved in quality, from the lowest workforce to the highest management has to be involved in quality management in quality. The fourth one is the process approach. So in quality management system, is approach process is very important. The process, the approach is the quality is going to be managed by process. And then the fifth one is the sorry, as I mistype, quality continual improvement. So in this case, the improvement is a long life process. Every time there must be an room for improvement. And then the seventh one is a factual approach to decision making. So decision is going to be made by the factual. And the last one is a mutual beneficial supplier relationship. This means that we have to be working together with the supplier to make the quality result is good. Let's move on. Now, what is the quality assurance? Quality assurance is focusing on the quality of product through planning, systematic activities by validation, control of process, and environmental and documentation. The goal of the quality assurance is to improve development of the process to avoid or minimize the defect. So in this case, in quality assurance, is the goal is how to minimize defect in the process for example, in the manufacturing or in the fabrication or in the operation as much as possible. And the ISO 9000 defines the quality assurance is as a part of quality management that focus on providing assurance that quality requirement will be fulfilled. And the function of quality assurance is to carry out self-inspection and quality audits, investigate and record any deviation in result, ensure that in-process control, calibration, and validation are carried out, ensure that regular evaluation are carried out with the objective of verifying consistent of process, and to establish a documentation. So this function is for the quality assurance guys is the daily activities like conducting the audit. We have the audit, regular audit every years and every certain time, certain months, and we will discuss the result of the audit with the management, because in this case is management is the leader of the quality assurance. Then what is the quality control? Quality control is to assure the product comply to the specification. Before making any specific any product, we have to prepare first the specification. So the quality control is to make sure that everything is as the purpose, which is the specification. And the goal is to improve final product by identifying the defects. The task of the quality control man is sampling and testing and the process quality control test during and after manufacturing. So the function in this case is to perform the inspection, to perform the in-process quality control test for samples, perform testing of raw materials, performing testing of finished product before dispatch. So in this case, the quality control will conduct the inspection from the raw until the material is ready to deliver to the customer. I mean, in this case, in the oil and gas company, the customer is the operation people. So what is the difference between quality the quality control and the quality assurance? After having a previous slide, so we can compare what is the difference between quality assurance and quality control, because in many cases the quality assurance and quality control is always say together, quality assurance and quality control. The quality assurance is a process oriented, while the quality control is product oriented. So the quality assurance is make a rule how to make the quality as we propose, while the quality control is to control this rule in the application in the day-to-day activities. The quality assurance aim at the defect prevention, while the quality control is aim to at the defect identification. And the QA goal is to improve the process to avoid defect, while the QC goal is to improve the final product by identifying defects. Quality assurance is a company based. As I mentioned, that the quality assurance is led by the management, while the quality control is laboratory based. In ISO 9000, quality assurance is defined as to provide confidence to achieve the quality requirement, while the quality control is to fulfill the quality requirement. So the job of quality assurance is to first make a documentation, validation, and process and environmental control, while the job of quality control is the sampling, testing, and documentation. So daily activities is testing, inspection. That's what the quality control main job. Now let's move on to the quality assurance and quality control in oil and gas. Let me give one illustration. If you are traveling on the road or on the highway from, let's say from Surabaya to Malang, and we get the fuel running out, so what we are going to do is to find the nearest gas station. Talking about the gas station, we will think how the gas or the fossil fuel coming from the ground, from the rock, below the ground, until the serve in the gas station. So the first thing is we are making the feasibility study. After having the area or the block that offer to the company, we will have to make a feasibility study whether this resources is feasible to explore, or even to exploit or not. How big the reserve under the ground, what is the content, whether it is gas or it's oil. After that, we go to the conceptual design. The conceptual design will decide what facility will be built to take the reserve from the ground. Whether we are going to make a platform if it is offshore, or we are going to pull it from the from offshore to the shore to the land and make the facility in onshore. That's it on conceptual design. And then after that, we will make a pre-feed front-end engineering design. In sometime some company will conduct a pre-feed or sometime will not. Or pre-feed is the continuation of the conceptual design. If it is going to decided to make a platform, so what kind of platform, whether a 3-leg or a 4-leg or a monopod or something like that. Here after pre-feed, we continue with feed front-end engineering design. But sometimes these two not in some company is going to join together. After feed, we continue with detail engineering. Detail engineering is make a very detailed work scope. What's going to be built? How long the pipeline, or how the pipeline? What is the method of laying the pipeline? If it is on offshore or and anything like that, whether we will make a subsea Christmas tree or we will make the Christmas tree at the platform. After detail engineering, we know what going to be procured. Usually the one that we, not just usually, but it is mandatory that we will have to procure the long lead item, which meaning that the material that will be processed, the raw material that will be processed, it takes a long time, something like line pipe, how many kilometers line pipe, the cable from between the facilities, how many kilometers of cables, how many tons of plates. It will be processed the procurement at the beginning as the long lead item. And then once everything is procured, continue to the fabrication. Fabrication is usually in the fabrication yard. Then the construction. Construction means if it is a platform, construction will be at offshore, or if it is onshore, will be at the field. Then installation. The platform, for example, I also always take the sample as a platform because mostly my experience is in offshore. The fabrication and construction will be conducted in the yard, in the shore, in the fabrication yard, and then after completion, it will be towed and bring offshore for installation. After installation, we start with pre-commissioning. The pre-commissioning is we will be testing the system by system. And then when every system is already tested, we'll continue with commissioning as an integrated system. Then when commissioning is conducted and complete and successfully, we'll deliver it to operation for startup. Let's see the summary of QA/QC implementation. So the QA/QC is conducted firstly is early stage of project. This is a very beginning of the project, from the feasibility until the maybe feed or pre-feed. And then the engineering stage of project, intersection between feed stage, and then the construction and installation stage of project. This is mostly quality control function, but the quality assurance should always come along together because they are doing the audit, they are doing the document verification, something like that. And then also commissioning, we will have to conduct the quality control and collecting the documentation and startup and operation. Now move on to Industrial 4.0 in QA/QC in oil and gas. If there's a question, is it possible for Industry 4.0 in QA/QC in oil and gas? Or the answer is certainly yes, because some of the oil and gas company, especially the big company, already started the implementation of the concept of Industry 4.0. Now the basic concept of Industry 4.0 in oil gas industry is Industry 4.0 is identical with the fourth industrial revolution. The concept is to push toward the manufacturing digitization to make improvement in efficiency, cost, and profit. In general, today's oil and gas refineries have to produce highest quality product to retain competitiveness with other competitors and satisfy customer requirement. The essential and key is to sustainable economic success for any oil and gas industry is to focus on quality management. Through the concept of smart refinery, by implementing the cyber physical system, Internet of Things, Industry 4.0 provides opportunity and challenge for quality management. An integrated information system will transform the oil and gas industry into smart manufacturing. Using real-time and high-value support system will enable smart oil refinery to respond customer requirement with minimizes energy and material usage, but providing the improved sustainability, productivity, innovation, and economic competitiveness. So as you are aware, as also mentioned by Pak Anang before, that currently the environment issue is encouraged by all parties. So by applying the concept of 4.0, one of the competitiveness is whether we are comply with the environmental requirement or not. As much as we comply with the environment requirement or regulation, we will have a good high rank of competitiveness. So by 4.0, we can make our refinery, our facilities as efficient as possible and as clean and as green as possible. Now the challenges and opportunities. As I mentioned, one of the smart process manufacturing characteristics is operational flexibility. It is able to respond to new situation caused by any external factors. The ability to the operational strategy from one mode to another is becoming essential. The challenge is how to choose the correct set point quickly. So sometimes the requirement is changed rapidly in a matter of days, it can be changed many times. For example, when the demand is high, we have to set to a high product, but sometimes when the demand is very low, we have to reduce the production. And then the safety and environmental risk management. The smart manufacturing should not only be focused on maximizing the economic competitiveness, but also on the reduction of the safety and environmental hazard incident. Therefore, safety and environmental risk intelligence should be an essential feature in the process manufacturing. As I mentioned before, as now the issue is environmental issue is very sensitive right now. So the company who has a good risk management and safety control and environmental control is will have a good competitiveness. And then the challenge of planning and scheduling. The optimal planning and scheduling of operation in an oil refinery by mathematical modeling and logic optimization provide opportunities for saving costs, increasing profit, and improving energy efficiency and demand satisfaction. The challenge is how to set up the simple but suitable model to replace the operational conditions. So in this case, the planning is very important. They have to manage when we have to shut down the plant without disrupting the production. We don't want then when the demand is very high, we have to shut down the facilities for any cause, maybe because the equipment failure or because of the duration, because for some equipment it has the running hours, a certain 1,000 hours they have to put on shutdown and to inspect all the things. Now, what is the sample? Is there any sample of the 4.0 in oil and gas company, especially on QA/QC? Yes. And before this, I made this presentation material. I have discussed with friends, with my community who are still working in the oil and gas, especially in QA/QC sector. Because to be honest, when I retired, the 4.0 is something that is still above in sky. So I just heard something about 4.0, but I don't know what is 4.0. But after having discussion with them, I get the info from them a lot. So I thought them, is there any material, or do you want me to convey something to the academic community about the 4.0, especially in the word of QA/QC? And this is what I got from them. The first thing is digital twin. Maybe I think many people, many presenter or if the Keynote speakers already aware about the digital twins. Digital twin technology is one among the 10 strategic technology trends found by Gartner in 2017, and it is the basic technology of industrial of 4.0. Digital twin is a virtual model of process, a product, or a service. Digital twin concept represent the convergence of the physical and the virtual world, where every industry, product, industrial product will get a dynamic digital representation. Digital twin model refers to a virtual model that completely corresponds to and is consistent with the physical entities in the real world and can simulate its behavior and performance in the real-time environment in real time. In the oil and gas industry, the digital twin can be generated by software, such as, for example, the Plant Design Management System, PDMS. This is the system that commonly used in not just in oil and gas company, but in the refinery or something related with that. So digital twin is making a twin. It means a twin. Twin is really twin, but the twin of the equipment, but it is a digital. So the twin is the representation of the one in the facilities. It can be an equipment or even a complex facility, the whole manufacturing of oil and gas. Once it is completely digitized and it is completely twin, I mean, once the refinery completely digitized, so people who wants to visit the site, the facilities or the manufacturing or the refinery need not to go to the facilities itself, but you just simply put your Google, your VR Google, and then we can go inside into the facilities like real. We are in the facilities. That is once I thought this is, man, is it real or just a game? But according to my friends and colleagues who are now still working in the oil company, yes, it's real. That is what their intention. That sometime if people want to inspect or want to make a development, need not to go to the site, just go to the computer room and put your Google, and you can visit your plant. So digital work, how digital twins work. A digital twin requires 3 different elements. Firstly is the original object, which is the equipment or the refinery. Digital twin. The secondly is digital twin as a virtual object, and the third one is the information links between these two. The original object has sensors that measure most important data for optimization. This data is forwarded to a system where it is processed and evaluated. On the basis of this data, the digital twin can simulate future values and emerging problems among other things, so that process and services depicted can be improved.
Excuse me, Mr.
Yes.
Nana Sutikna, your presentation time is 5 more minutes.
Okay. Okay.
You have
Okay.
5 more minutes.
Okay.
Thank you.
I will speed up. Okay, I will speed up. Okay. So imagine the digital twin is the object is like a human in the ICU room. So all the body is provided with sensor. Where the sensor is sent to the digital to the twin in the computer room. And there are 2 ways to feed the digital data. The first one is real-time data from the equipment, and the other one is we can insert that data from the operator to make a simulation. So this is just the illustration. This is the physical twin. This is the physical object, and this is the digital twin. And in between there is a data optimization flow process. The benefit of digital twin is first one in research in research space, digital twin can be used to illustrate the diverse effect of different decision by simulation. The second one, production phase, digital twin can help to work more efficiently. Operation phase, availability or maintainability and planning can be optimized. Digital twin can reveal individual weakness of the product, so it can predict when it is going to be out of service. Actually, this just let me explain in the brief about the second one is remote inspection. It's easy actually. Remote inspection is inspection, but we are not going to the facilities, but we are by using the internet. We can do the inspection from the office. Here, just the illustration. This is the facility to be inspected. The inspector is going to be using the handheld monitoring, and then in the other hand, the clients, the expert, and other parties who are interested in the inspection will join together in the meeting room. So we need not to go to site. Especially this is very good for this condition where the traveling is very limited, so we can go. We can do the inspection from the office, and the benefit is easy to use, easy to set up, no waiting time for inspection, faster, quicker access, allow complete cycle of inspection, reduce travel risk. This is very useful right now. Reduce exposure to hazardous area. This is my presentation, but I will conclude this presentation with the first one is the quality assurance is focusing on product quality through planning, systematic to avoid minimize product defect, while the quality control is to ensure product comply to the specification to improve final product by identifying object. Quality assurance and quality control started since the early stage of the project until it is going to be operated in the operation. And the application industry of 4.0 or for the industrial revolution is essential and key to sustainably economical success in oil and gas. And through the concept of smart refinery by implementing cyber physical system, Internet of Things, Industrial 4.0 provide opportunities and challenges for quality management. The digital twin technology can not only make to establish virtual models, but also the simulation of virtual model to predict the unknown, something unknown that we cannot predict before, and find the correction. While the last one is the remote inspection technology is useful to complement the digital twin and is suitable for the current condition, especially during the pandemic season. That's all my presentation. And now I return to the moderator. Thank you very much.
Thank you very much, Mr. Nana Sutikna, for such detailed and thorough presentation. Now we have come to a session that I believe all of you have been looking forward to, that is question and answer session. So if you have any question to our presenters, please take advantage of raise hand feature, and then we will help delivering your question to our presenter. If you have any question or response or further interest in the last three keynote speakers' presentation, you may address it in the session. Okay, in that case, I would like to ask one question to all three presenters. So what are your suggestions for the field of education, for educational institution related to the development of your field? Thank you.
Who will answer first? Oh, Pak Anang.
Pak Anang, yes, please.
No, I think please. Okay, thank you. For me, I think, yeah, I believe that technology 4.0 is the most important now. So in any field, I mean, sorry, like in generation, in transmission, in distribution, in customer services, in any kind of business in PLN, always requires this. So we cannot always depend on the foreign, for example. So I expect that the academic world, I mean, like academic institutions should increase or add some more attention for this field. And please always have a communication with the big company, national company, to support this. Give an idea, give maybe introducing some innovation, and I think we can make a collaboration. It is from me. Thank you.
Okay, so the keys are innovation and also collaboration, sir. Okay, thank you, Pak Anang. How about Mr. Nana Sutikna?
Okay,
How
thank
can
you, Mbak Maya.
Bridge the gap. Thank you.
I just want to add what Pak Anang already mentioned, that Industrial 4.0 is in front of our eyes. Like or dislike, it will come to us, and if we don't take it, we will be left behind by the industry. So the important thing for the education is please be prepared for the moving forward for the industrialization, like this, because the technology is moving very fast.
Okay.
Very fast. When I take my retired, as I mentioned, 4.0 is just something that I heard very. I don't know whether it is what is the creature of 4.0, but right now
it's an idea.
Some refinery, some oil companies already apply this. So be prepared for this. As this, at least you prepare the manpower of the technology to welcome the 4.0 technology coming to our country. Thank you.
Thank you, Mr. Nana Sutikna. How about Dr. Anggit? Any final remark?
Yes, okay. I think our spirit is to get more creativity in our own field. So it will be a kind of innovation that we can achieve in the future. So I think that's it.
Okay, thank you very much, Dr. Anggit Murdani. How for our first and second keynote speakers, is there any remark for Professor Funabiki and also Mr. Rosli Omar? If you have any remark or response to this issue, how to bridge the gap between the industry and also our field of education, We would be happy to listen to your response. Professor Funabiki or Mr. Rosli Omar?
So actually, I have some experience working in industry. Actually, it's a manufacturer. So it was, I think, 30 years ago. So maybe it's changing. So with this experience and also the longer experience in the academic, so I know that there's some gap between the industry and education. So through both experiences, I think, of course, they are different. So the difference is important. So we should understand, expect the difference, the role of each part. So education society should have some duty. You have to educate the young people. So develop innovative technologies or something. Maybe my work is not innovative. So at least I understand our project cannot make money, although it's important. So such things. So education is a most important role in the school, I think. So I think it's different from the industry. Industry, of course, I have to educate the people, but for more some limited direction. I mean, for the industry, company, most important thing is make money. It's my understanding. So they can invest, educate the people to make how to make money. Okay, the direction. But then often that company meet some limitation, I think, obstacles, not diversity, I think. So I think educations, maybe academics, may have the different roles. They don't say, they can, they teach, they study. So not only the benefits for the industries, I think. So we should say, whatever, I think we should do whatever we want. If we are interested in something, we should do, I think. I try to encourage the students, please give us your ideas, own ideas, okay? So I think, so of course we have to understand, we have to watch the direction of the industry, particularly IT, my field, is very fast changing. So, however, not only that one also, so I think, so each, I'm sorry, my opinion is too long. So each side has own law. We should respect each other. That is my opinion. Sorry, long. Thank you.
Thank you. Thank you very much. For our second keynote speaker.
Okay, thanks for giving me the chance to answer your question. I think the question is how to close the gap between education and industry, right? So basically, I think in developing country, I think the collaboration between the industries and university, I think, are quite low compared to developed country like Japan, like UK, like Europe countries, like US. I mean, we are like behind them in terms of collaboration between education and industries. I think, but we cannot stop here. We cannot keep quiet. We cannot stay calm. I think we have to move forward in this direction. And in fact, our university currently, actually, we try to increase or to enhance the collaboration between our university and industries, where we try to find projects in industry. Sometimes in industry, they don't have people. They don't have expertise, to design a system, something like that. Because just 2 or 3 weeks ago, we we were invited by a very big company in Malaysia. It's a very big company. I think maybe top 10 or top 20. Top 20. They invited us to design an EV scooter, and we are very proud, to be given that chance to involve in that design. And because industry, they are very quick. They want the product to be realized between maybe 1 to 2 months. So we have to follow the schedule. Because in academic, we are very busy because we have a lot of things to do. We have to do teaching, we have to do research, we have to do public or CSR, corporate social responsibility. Yeah, we have a lot of things to do, and sometimes we can't cope with the industry requirement, but we try to do that. I mean, as a management of the university, I think we can reduce the workload of the staff in teaching and something like that. But we ask them to focus more on the industry collaboration. I think this is a way forward. Countries like Malaysia, Indonesia as well. Okay, we try to enhance our collaboration between industry and universities. And I believe in 10 years' time, I think maybe we are at par with Japan's or like Europe's countries or US, maybe, I don't know. But I can see the direction now. Okay, I think that's all from me. Thank you.
Okay, thank you. So one final conclusion that I can draw from our presenters is that change is inevitable, and as an educational institution, we should motivate our students to make innovation and to be creative, and educational institution should also develop networking and collaborate with the industry. All right. On that note, I would like to invite all of you to give a round of applause to our keynote speakers by waving your hand. Thank you very much for our keynote speakers. And I'm going to give the session back to our MC. Thank you.
Thank you very much. Ladies and gentlemen, we have listened very insightful presentation in the keynote sessions. Many thanks are delivered to the keynote speakers. I'm very glad that I see so many participants are staying behind to attend this keynote lecture. Thank you very much for the fruitful discussion. We kindly invite the presenters of the technical sessions to join the parallel session for each team from 1 p.m. The Zoom ID has been provided in the website as well as email. The organizing committee would like to announce that the attendance sheet of the keynote sessions has been shared in the chat box of Zoom. And regarding the seminar kit, the organizing committee will send the bags, t-shirts, memory sticks, and so on to the participants' postal address. Therefore, we kindly request the registered participants to complete the participants' data form that has been sent to you by your email. Again, the parallel sessions will be started from 1 p.m. at the Zoom room for each specific team. Please note that the Zoom room is changed to the new room with the specific ID for each team provided in the website as well as email. Thank you very much and see you in the parallel session.